Okay. So I'm not on mute right now. So we will start with equivalence partitioning again, just to quickly cover all the points. Or let's start with boundary value analysis. So what happens in boundary value analysis is like, imagine that there's a field which accepts values 18 to 56, right? So instead of testing everything between 18 to 56, this boundary value analysis says that if you test like first what you have to do is like divide it between valids and invalids. That's what I do always. So what I do is I would write 18 to 56, a number, or like make a line. So have a paint. So what I would do is like my way of doing is like I will divide it. I will divide it into valid and invalid parts. So which is like equivalence, but this is like very helpful and it helps me all the time. So it says 18 to 56. So here it's 18, here it's 56. So anything inside this is a valid input, so valid, and anything here is says invalid. And even here it says invalid. So as per boundary value analysis, it it means we have to test for here, we have to test like 17, we will be testing 18, we will be testing 19. So input values would be 17, 18, and 19, which is around this boundary. So minus 1 from this number. So minus 1 from this number and plus 1 from this number. So 8, 17, 18, and 19. So if we test for 17, if we test for 18, and if we test for 19, that means all this part is completely tested. Now we go to the next one, which is 56. So here again I will do the same logic, minus 1 plus 1. So I should be testing 55, I should be testing 56, and I should be testing 57. So for 57, it should the output would be invalid, and for 55 and 56, output should be valid. Similarly here also 18 and 19 is valid, and 17 is valid, invalid. So that way, by just checking 1, 2, 3, 4, 5, 6, 6 input values, we have tested everything about the field where only 18 to 56 could be entered. Any questions in this?
No.
No.
No. So this is clear for the entire team.
Sorry, I just wanted to ask like why we're not adding other numbers to like the invalid, or why it's just 17 on one end and then 57 on the other end.
So
Why aren't we going
why
like
not 0,
15,
1,
16?
2, 3, 4, and things like that, right?
No, I'm like, why am I adding like maybe like two other values or three other values, like 15, 16, 17? I'm just trying to understand like the reasoning behind it.
Reasoning as in like why are we testing these numbers? That is your question.
No, I understand why we're testing these numbers. My question is why we're not adding more values to the test, like maybe like two more. Because I'm thinking, is that exhaustive to just do 17 and 57?
Oh, so like why are we not adding 20 and 21 also in between? That's what you're saying?
No, I'm looking towards the invalid section.
Okay, so
Yeah.
instead of 55, 56, 57, you're saying why are we not testing 58?
Yes, like maybe a value after 57 and a value before 17.
Okay, oh, so why are we not testing more? Because uh, the the ideology of doing an optimized testing is if 17 is invalid, then it is consider that all the numbers before this will will be invalid. As in, like, it is considered that it will be invalid. So even if you put like 0 or 1 or 2, it will always be invalid. So instead of testing all the number, we have come up with this technique, or which is called boundary value analysis, which says, like, if one number before that is invalid and it's working fine, then the coding has been done in a way that all the numbers before that will be invalid. So we don't have to test it. That's what.
Okay.
Yeah.
Thank you.
No worries. But this topic is clear for all the three. Please say yes, and then I will proceed on the next one.
Yes.
Okay.
Yes. Yeah.
Okay, so let's go to the next one. So this is boundary value analysis. Let's go to equivalence partitioning. This equivalence partition. I think this is equivalence partitioning. Okay. And in equivalence partitioning, like how I said, like all these things are like very closely related. So what I did was, like, first I divided this uh this 18 to 56 into valid and invalid, and then I chose like the boundaries, right? So here also is the same. So whatever I've explained for just valid and invalid thing is coming from equivalence partitioning. So let me clear this file, new. One second. So equivalence partitioning is like you would draw a line first. Okay, here it says accepts 18 to 56. Yeah, so same testing technique, but there's a small catch here. I will say what is the catch. Okay, so what we do here is, like, again, divide the input. So here we are taking 18, here we are taking 56. We are dividing into invalid section. Here this is valid section, and this is invalid section, right? So equivalence partitioning is nothing but first you divide the inputs into invalid section and valid sections. So for 18 to 56 is valid. Before 18, any number is invalid. And before 56, any number is invalid. Oh, sorry, after 56, any number is invalid. So what equivalence partitioning says is, if you take any number between this and test it, it has to show invalid input. So taking one number and testing it will do your work. Similarly, any number between 18 to 56, if you take it and test it, you would attend the thing. So I can take 20, I can take 25, I can take 54, I can take anything. I just have to test one number. So if I test one number, it will say that, okay, I have tested this entire section instead of testing all the numbers. So this is one. And similarly here, I can take 59 also. And 59 should also say invalid. So that's the scene. So here, what we are doing is we are just trying to divide the into valid and invalid, and take only one number from this entire section, one number for entire section, and one number from entire section, and test only one number. If this test is passing, then all the tests in this section will pass. So that is the ideology of equivalence partitioning. But however, all these two are done together in order to achieve like best testing results. So what we do is, like how we did, like how I explained in my previous example, I made a line. I first divided into valid and invalids, and then I took like a number here, like 17, 18, 19, and from here I took like 54, 55, 56. Oh, sorry, 55, 56, 57. So those are like my boundary values, and then these are my equivalence partitioning. So any number from between this, any number from between this, any number from. So in equivalence partitioning, the only difference between these two is, like, from here you will just choose one value for invalid, one value for valid, and one value for, like, one value from each section. That's what I would say. So if it is invalid, so you'll just choose one value from here. If it is valid, you just choose one value. If it's valid, you will just choose one value. And yeah, that's the only difference between equivalence, partitioning, and boundary values. For boundary values, you have to test all these three fields, three numbers. And in equivalence partitioning, if you test one number that tells that output's invalid, then that means your testing is complete. You don't have to test all the other numbers. And in computer or like in testing scenario, you will use combination of both to do any testing. Any doubts here for equivalence partitioning or boundary value analysis?
It is clear.
Okay.
Uh,
Yes. And right now we are seeing example with just one what we say one input, which is 18 to 56, but there could be several ranges like how we have it in our assignments. Let me quickly open the assignment or coursework. Let's do this right now since we are here, right? So here it says 1, 2, 3, 4, 4 times. So let me quickly open my pane. Android. So what here it says. So let me make it money. So I'll draw the line 20K. Then it's 60K. Then it's 80K. 100K. And then it's non-resident. Non-resident.
I'm sorry, sure. I have a question.
Yeah.
I've noticed, like, with boundary value and equivalence, is numbers they've been using. So for like you've been using values like numbers or yeah, but for non-residents now, how would you just write non-resident like in the test case? You know, if there's no value for that, so would you just write it like non-residents in the test case?
Yeah, you
Like,
will have to write like non-resident in the test case.
oh, okay, okay.
Okay, we will cover the topic. Like while we are discussing this, we will cover the topic also. Okay, so let's see what it says. So before directly jumping into it, let's see what it says. It says RBC is a leading bank in Canada. You have been hired by a bank to test out their mortgage calculator. So there's a calculator which you are testing. The calculator uses customer resident status. So it needs one input here, which is like customer resident status and income to work out a mortgage interest rate. So it says like you have two inputs. First input says the customer's resident status, and second says the income. So what is the income? The business rule is as follows. A resident with an income of less than or equal to 20K. So person has to be a resident and uh, their income should be less than or equal to 20K. If it is, then the output will be declined. The second is a resident with income less than or equal to 60K, then they will get like 5%. And if a resident is less than or equal to 80K, they'll get interest rate of 3%. And a resident with income less than or equal to 100K, then they will get like 1%. And for non-residents, it is directly declined. So what are cases? What are the design techniques which you would use to derive your test case? List out the test cases. Okay. So you have to write like test case here. I haven't explained you on writing test cases. So before even going to answer this, should we go and yeah, I think it would be a good ideology to first go to test use case or test case and then come here so that you would know how to write the test case. But however, right now, are we clear with what is equivalence partitioning and what is boundary value analysis?
Yes.
Okay, perfect.
Yes.
Yes.
Okay, let's go through.
Sure.
Yeah.
Oh, you also mentioned something about the decision tables. Yeah.
Yes. So I'll be talking about decision table first, and then closely move to use cases, and then go back to assignment. So let's do that, or else writing the test cases directly without explaining what is use case, it will be difficult for me to explain. Okay, so decision table is nothing but it's a black box type of a testing, and here you have combinations of input. So let's quickly see what the combination of input means. Where did it go? Let me open an Excel sheet. Does anyone know anything about truth table? Did you ever hear about something called truth table in your life?
Yes.
Yes,
Yes.
mechanical
Yes.
engineers, yes, for sure. You would have heard it. So what truth table says is like there's a there are two input. So input one, input two, and then there's an output. Or there could be more inputs also, like it depends. So what are like if the inputs takes like of values in binary, so it will be like 0, 0, then it will have like 0 and 1, then it will have like 1 and 0, and then it will have like 1 and 1. So what are the different combination of inputs? So these are the so and you can make these zeros as whatever you feel like and 1 as whatever you feel like. It does not have to be like on and off or like binary digits, but it can be anything that you feel like. So two inputs and then output. So if both inputs are something, what will be the output? One input is 0, 1. So let's take it an example as like there's a field, okay? User email, sorry, email, ID, and password.
Sorry. Sure.
Yeah.
I have a question. Your notes, where can we find it?
Oh, my notes, I think, oh, I forgot to send you, I guess, this notes. I sent only to Addy. I thought I would have sent to all. Maybe I forgot to send it. Hold on.
Yes, you sent it to me. I thought you copied everyone actually.
Did I not send it to everyone else? What is this? Okay. Addy. Oh yeah, did I not copy everyone else? Oh yeah, I forgot to copy everyone else. I just sent it to everyone. That was my bad. Okay. Sorry about that. I don't know how I missed this. I thought I've sent it to everyone, but forgot to do it. Okay, no worries. I will send it today. So sorry about that. Like, oh, without these notes, it would have been very difficult for you guys. I missed it, or maybe something. No worries. Okay. Then how did you guys manage to do the assignments without notes? Oh,
A lot of reading.
yeah, I'm so sorry about that. I thought
Yeah,
I
we
shared it
browsed.
to all. Oh, I'm so sorry. I really apologize for that. I kind of missed you both in that email. Okay. I'll share it today. As soon as the class ends, instead of waiting until the next day, I will share it on the same day. Oh, so sorry about that, guys. I think I might just take off the marks from this one. Because yeah, I didn't even give notes. So yeah, I'll make it like a neutralized for this one and then put both the marks what this assignment would have given us into the next assignments or the next session. Yeah, without notes, it
No
would
problem.
be very difficult. Yeah. So yeah, Let's do that. I would come up with some solution, no worries. Coming back to our
Thank you.
yeah. Yeah, again, sorry for that. Okay, coming back to our decision table. Okay, let's go with a very easy example, which is like a login. Okay, there's a login functionality. It accepts email ID and then it accepts password. And you click on login and you will get the access. Okay, just simple. So it has two input. So this is input, this is input, and this is output, right? So it has two input state and one output state. Okay. So if I don't enter, so this is my invalid input and this is valid input. Okay. So what I did here is I kind of made 0 as invalid input, 1 as valid input. Okay. And I have these various combinations. Okay. So if there are two inputs, what are the four various combination it can have is these. So this could, these two input can only have four different combination or like four different combination is possible. And how do we decide that it goes with the formula of 2 to the power of x, 2 to the power of x? It's very easy. It's not very difficult. So imagine that there was only one input, right? Just if it had only one input, it's like enter the age, press enter. So that is one input, right? So if there is one input, then what are the possible combination? So 2 to the power of 1, which is equivalent to 2. 2, I don't know, I can't write it here, I guess. 2 to the power of 1. So 1 input will have how many number of combination it could have? 2 to the power of 1, which is equal to 2 combination. What are those combination? It could be 0 and 1. Any difficulty in understanding this one? What I mean by this? So let me explain it again. So there is one field, okay? Let it be that that field is like what we saw it here in our presentation. So imagine that this is the field, age. You enter the age and press enter. Okay, it will tell you valid or invalid. That's it. So imagine there's a web page which tells you if you are a valid age, if you are at a valid age to apply for a job or not. Okay, so it will ask you to enter the age, correct? And the condition in the application or the web page is that if your age is between 18 to 56, it will tell you valid, you are eligible. But if you enter anything other than 18 to 56, it will say you invalid, right? So what is the what it means here is like you will enter something uh either valid, so you will enter either 18 or you would enter 58. Okay, and these are like the two options, so either valid or invalid. So valid and this is invalid, and then you press input. So if you press enter, it will say valid, and if you press enter here, it will say invalid, like you're not eligible or you're eligible. So make it eligible. Instead of valid, I'll say ELIGI, eligible, and here I'll say not eligible. Okay. So there is one field. What are the possible inputs it can have? It can have anything, but what are the possible output it can have? It can either have like eligible or not eligible, right? Those are the two outputs it has. So how you would design this is like 2 to the power of x is the number of inputs you want to test both the condition. So this is the formula you'll use, 2 to the power of x. So here, since the input is 1, so 2 to the power of 1 is 2. And what are the inputs which you are going to use? You'll be using one valid input. So here I will make as 18 and one invalid input, which is I'll use like 58. And then my output would be based on that. So I have tested both the conditions of the application. So I've tested application throwing invalid as an output and even valid as an output. So that's when we use, like this is one of the example where the field where the input was 1 and output is like double. The next we would see is email ID and password and the login functionality, right? So what we have done is email ID could be valid and invalid, right? So I've made it like 0 and 1. 1 is valid input, 0 is invalid input. So if my email ID, which is input 1, so I'll make it like email ID. If my email ID is invalid, if my password is invalid, what will my output be? Like no login. So this is what it would design. So output is no login, which is like, let me cut this, paste it here. So output is 0. So output is also not like a valid login. Second, my email is invalid. My password is valid. What my output will be? If I've entered like invalid email, but a valid password, my output will be that output would be again 0, which means,
0.
yeah, which means no login, right? The third one is I have entered correct valid email, but I have entered invalid password. So what in this case, my application will again, output will be what as per you guys? I've entered correct
0,
email
2.
ID, but my password is not correct.
Should be 0.
Okay, so that means like no login, right? And the final is I have entered valid email ID, I have entered valid password, and my output will be what? With valid
1.
valid
Should be
password,
successful.
successful, yes. Login successful. So you see that there are two fields with two options, either valid input or invalid input. And what is the decision what it has to take? Either give access or don't give access, right? So this is when we use this. So your number of inputs has to be less, to be honest. It can't be like if there are like 10 fields, you can't do this. I mean, you should do decision table, but it's very difficult to do that. Imagine that there are like 10 fields of input and then 10 fields of out, and then there are various outputs. So this 2 to the power of 10 will be like so much. So you have to be like a little bit careful on like the number of inputs you have and what are the number of output conditions you have. On that you have to decide. So if it is like 2 3, sometimes maybe 4, it's fine, but anything beyond 4 will be like too much to handle. So let's not do that. If my input status is like more than 3 or 4, we will not use decision table. Okay, so right now I have explained you about 1 here. So 1 is done. I have explained if 2 input is there, then how the system will perform. So this is your decision table. This thing, this you will be designing this part. That is, you're designing decision table, right? So this is what it will be. Again, these decision table and equivalence partitioning or those things, you just have to keep in mind while testing an application. There will not be any place where you will be writing decision table. It will just be in your head that while testing this application, how will I write test case? So my test case should say, okay, enter and valid, enter invalid email ID, invalid password, and make sure that login is not given. The second test case will be enter an email ID, enter an invalid email ID, valid password, and make sure that login is not given. So something like this. So this will help you derive your test case, but you will not make this table anywhere like while working. It will just be in your head. So I've explained 1 input, I've explained 2 input. Now let's go and see with 3 inputs. What if you have 3 inputs, right? So you have 3 input, as in imagine that there's a field which accepts email ID and it also accepts user ID, right? Your banking application. I have my banking application with Scotia. It sometimes helps me log in with email ID and also it has a user ID. So I can log in with anything I feel like, right? So here what we see is like the field are two fields, which is like one, you will see only two fields, but the values it is taking is three types of values. So I will write it here. So one is email ID as one value. The next is user ID, and the final one is password. Correct? And output. So again, how many inputs we have? We have combination of three inputs. So my 2 to the power of 3 is what? It's 8. So I hope we all know the power. So power is nothing but 2 into 2 into 2, right? 3 times, and it's 3, and it's 8. So 2 into 2 is 8. Okay, now how do we decide this table? So what we do is, it's very easy. What I do is like, first you make all 0. I have an easy way to do this. It's like, since we know that there has to be eight rows, what I do is like 0, 1, then 0, sorry, 0, 1, then 0, then 1, then 0, and then 1. So this is this design. What? Oh, sorry. Then 1. This is like an easy way of filling this table up, which will give you all the
Sorry.
possible combinations. Sorry.
Yeah, sure. Like, how did you fit in those binary numbers? Is it just random? Did you just randomize it? Like, like the first column was 000, 4 zeros, then 4 ones, then 0. Did you randomize it? Like, if I put, like, on email ID, I put 1111, then 000, like, is there any order to it? I don't know if you understand my question. Like,
I,
how did you?
sorry. Your question is a little bit not understandable. So can you repeat
Yeah,
it
I
again?
said, like, the way you added the zeros and ones, the binary numbers, is it based on experience or just like, for example, on the email ID,
Yeah.
what if I choose to put 1111, then 0000? Then under user ID, I start with 1100. Like, if I like change the numbering, I don't know if you understand what I mean. Like, how
Oh,
did you just?
okay. Oh, yeah. So this is a technique, I would say. This is like a technique which says if you have three inputs, right? If you have three inputs, then first you have to make this decision table. And this numbering is like standardized. It is not like I memorized or you have to memorize. This is like a standard way of writing. If you have ever learned about truth table, this is like the truth table where if you have three inputs, then these are the maximum combination of those three inputs. So like when we had one input, what are the combination of the inputs? Like it can either have like 0, which is like valid or invalid, right? So just two conditions we have. So similarly, if we had two inputs, then what are imagine that state of input can only be valid or invalid. For decision table, you have to make sure that the state of input is valid or invalid. Yeah, that is like the very first thing which we have to know. State of input is valid or invalid. So your username is valid or invalid, password is valid or invalid, and login is either valid or invalid. So the state of input can either be valid or invalid. Only in those cases you can choose this. And if there is only like valid or invalid as like the parameter, uh, the different combination with three field will only be 8 combination of inputs. And for two fields, it will be like 4 combination. And for one field, it will be like 2 combination. Does it make sense?
Yeah. I guess I have to go back to my additional math.
And
Maybe answer will take us some math again or something, or maybe so
and
we'll like
let me complete this, and then you would know. Let me
yeah,
complete this topic. The topic as in like let me complete this three scenario, and then you would know that why do we use it? Like why do we use like this option? Okay.
yeah.
So you will see that all the three are covered. Like all the different scenarios are covered. So again, let me have the same invalid and invalid state here. Okay. So first, let me ask one question here quickly is what do you guys understand this part when I say that there is two input and oh sorry, when there is three input, we will do 2 to the power of 8 to understand how many possible conditions we have. So we have
Yes,
eight conditions. So do we understand this part at least? I want to understand this. Like when
yes,
we stand here.
Yeah.
Yes. Yeah.
yes,
Yes.
So similarly, like since there was one input, we had like two possible conditions, right? So that's why we wrote this one here. So 2 to the power of 1. Similarly here, 2 to the power of 2. Let me write this one also so that it's clear. 2 to the power of 2, which gave us output of 4. And this 4 is here, the 4 rows. Here 3, 8 combination. So first one is like in this fields, take it here, Control X, Control V. So what we did here is, so this input field can accept email ID or password. This input field can accept user ID or password and give you the application access. So what we are doing here is like first we are making sure that if we write here email ID, that means we will not test for email ID. So here it says you will not be entering email ID, right? And in that case, like how we would do that. So first case where you don't enter anything in input for email ID and anything in password, try to log in. It should say login failed, right? Where you're not entering either email ID or user ID. So you are doing this in one shot. Like when you don't enter anything, it's one shot, right? Rather than like you, because there is all these two condition is met in like one field. When you don't enter anything, this both will be satisfied. So both will be like invalid and password is also invalid. No output is given. No login. I mean at this point. Similarly, next,
Sorry, yeah.
yeah. So
I have a
next,
question.
yes,
So you're saying for the first condition, we're considering it as both invalid entry and you're entering nothing as well.
yeah,
Okay.
yeah. So invalid ID, as in you're not entering anything. Invalid user ID, you're not entering anything. Invalid password, so you're not entering anything. So output of the system is no. It will not give you any login. Similarly, next time you don't enter email ID or user ID, but you enter password, right? It will again should not give you login. So you will write this one. So you're not login. Third time you don't enter email ID, or when I say don't enter means even if you enter and if you enter an invalid one, oh yeah, I think I should have said invalid. So instead of saying not entering, I could also say that you have to input invalid values. So you can either leave it blank or fill something which is invalid, right? Yeah, so that's what I should have mentioned. Instead of saying empty, I would rephrase my sentence, say enter an invalid email ID or invalid password, and it should not let you log in. Second time, again invalid email ID but valid password. Then it will still not let you log in. Third time, you enter a valid user ID and invalid password, it should not let you log in. No login. Fourth time, this is not considered. Fourth time, since the field is same, this field is same, you enter a valid user ID and you enter a valid password, right? So what is the output? It should give you login. Login successful. The third one, valid email ID but invalid password, no login. Here, valid and valid. So here you have entered both valid scenarios. So you have entered valid email ID and valid password. So login is successful. Third one, you are saying you have both valid user IDs and valid email ID. You can enter any one of it, but the password is incorrect. So in that case, again, no login. And the third one is when everything is valid, like you can enter either email ID or password, and it should let you log in. Oh, sorry. And it should let you log in into the system. So that means it will let you log in into the system when only your username is correct, or username and password is correct, or your email ID and password is correct. And it will not let you log in any other scenario. So this is how you would design a state decision table, and then consider like, so what is testing in this phase? You are just testing is different combination, so that you should not be able to log in with any invalid data, or yeah, with any invalid data. So with invalid email ID, or with invalid user ID, or with invalid password, you should not be given access to the system. And how do you optimally do it is by testing all these various conditions, by first having invalid email ID and invalid password, or invalid user ID and password. Make sure the system access is not given. Then you will give one thing valid and other invalid, and then try the system access is not given. The only case the system access is provided is with valid information. And with the help of this table, or this decision table which you're making, it is possible to achieve that condition. So you will be testing all the possible conditions present in the system for this three different input fields, and this a different not different, I would say only two output state, right? So only when there is two output state. Perfect. Any doubts here? So output state has to be two. Number of input has to be minimal in order for us to use decision table. Any doubts or still confused?
Sure, I have a question. In the assignment you gave us, it was either email ID or user ID,
Okay.
right? So, and that's why there were three login successful. So just to confirm, if it was and like email ID, like the three of them are compulsory, not like email ID and user ID must be given, for instance. So those first two that were successful would not be successful, correct?
Sorry. Can you repeat your question again?
In the question that you gave us, it was either email ID or user ID plus password, correct? So I now said if it was email ID and user ID and password, like you must provide the three of them, then it means um the values, the first two logins that were successful would not be successful. It will be no login. Like, for example, I don't know if you understand my question.
Oh yeah, I understand. So for your condition, imagine that there is three field instead of this one having one. Imagine if there was like this. Let me make it this way. Okay, I'll make it one more. So let me make it this way. So imagine that it was this. Control,
Yes.
make it this.
Yes.
Make it here so that we are clear. So imagine if there was 3 fields in the system.
Yes.
Imagine that you have this one, and this one. So okay, so
Yes.
let me make this as like a thing. So here now you're saying, so that time the functionality of login will be designed in such a way that if either of this field is filled, then it will give the login. If both are filled, then it will give the login. So something like that. So imagine, like, take one of this scenario here. First one, I have 0, 0, 0. I press login. So which is, you know what? Instead of 0, no, let me start using this word anymore. So when I have all the 3 as invalid, when I click on login, my system will say what? No login. What will the system say? So let me click on system, and system will say this one, right? No login. It will say no login. So next time what we do, we will try to put invalid input in email, invalid input in user ID, and a valid password, right? So we will a valid thing here. What will system say? Again, system will say no login. Why? Because these two are invalid, right? Third time what we do, we have like an invalid email, valid password. Oh, sorry, valid user ID. So we will have like a valid input, but invalid password. So again, system, when you click on login, system will say no login, right? Because it's not possible without any password, your system should not give you access. Third one, now is like a good way. So you have a invalid input, but you invalid user ID, but you have a valid email ID and valid password, and you click on login, the system will say login successful. Why did this happen? Because there is a condition here, condition which says enter either user ID or email ID for successful login. Okay, so this is your condition. There's a condition which says if both are present, I'm happy, I will give you access. But even if one is present and if it is valid, I will give you output, right? So something like that. Now, is this clear?
Yes, so I was just asking that if the condition stated that you must provide user ID and email ID and password, like if you have the 3 conditions,
Yeah.
then it will be login unsuccessful, correct?
Oh, if you
Like,
have all the 3 as valid,
yes, as in no, like if the condition states that the user ID, the email ID, and the password, all of them must be not all. Like it's not either you choose any of them. If you have, because I mean, I've seen some like you provide the 3 of them. But I mean, I'm just asking, like if you have a condition like that, sure, where you have to provide your user ID, your email ID, and your password. Like the 3 of them must be present for you to log in.
okay. If all the 3 is must, if you're
Yes.
saying that if it's must, then yeah, the login will only be successful here, and
Okay.
all this will be like no login. That's true.
Okay.
Oh,
Okay.
that is your question. Okay, sorry.
Yes. Yes. Yes.
Okay.
I just wanted to confirm. Yeah. Okay.
Okay, that's perfect. Yeah, that's correct. So I hope so Anselm and Tommy, I just wanted to I don't know if you understood the question or not, so I'll just repeat his question. He says, what if all the 3 fields are mandatory, right? Imagine that instead of 2 fields, what if all the 3 fields are mandatory? So you have to enter all the 3 fields like mandatory. So in order to get access to the system, you have to have like valid email ID, valid user ID, valid email ID, and valid password. So what happens in that case? So very good, what we say, very good insights, I would say, in this case. So we have like two different testing in a way. So if all the three fields are required, then make sure that if any field is invalid, if any field in this is invalid, the system will say login unsuccessful. And when only these three are valid, it will say login successful. And I hope we also see the difference between like these two different parameters, or like what if both are required and when only one is required, or when this is the input. So this is a very good example of a decision table on like different conditions of what the inputs would take, something like that. So do we understand decision table at least like 80% now? Is there any problem with understanding the decision table with anyone?
No, I understand.
Now you understand? Okay, that's nice. I'm doing an emphasis here on like why we need this is because we would be using these three or four combination in every stage of software testing. So like, and like no matter how much experience you are or you gain, you would be using these techniques. So even today, I'm using all these techniques to do my testing. Okay. Wow. So I would, let me save this document, because if I don't share it, then it will be bad. So decision table plus. Okay, so I'll share this with you. So you have different examples here. Let me control X, control. I hope you understood why do we have this 2 to the power of X? What does this 2 mean? 2 means like 2 state of an output. And to attend this, what is this power of 3? 3 is like the inputs. And I hope we all understand everything here, right? Okay, I'll close this, save it just for us. Yeah, and now, so we have covered when we have combination of inputs, not too many inputs. Like when we have to use decision table is like when we have combination of inputs and there are not too many inputs. And it also refers as cause effect. Cause effect is, I guess, uh, that for every input, there is an output. So there is a cause and there is an effect for that cause. Like for different kind of input, there will be different kind of output in the system. So here where so the formula which I explained, 2 to the power of X, where X is number of input determines the number of test cases. So in our scenarios, when we had like 2 inputs, we had 4 test cases. If we had like 3 inputs, we had like 8 different test cases. So I hope all this is clear and we can move next, which is state transition. State transition, I think it was easy. It was not like a difficult explanation, but let me do a recap on that. Where did it go? Okay. I hope it's this page. Oh no, it's not there. Week 1, part 2, where did it go? So we got into, oh yeah, so transition as in like how we will move from one state to another into the system. So so you have to make like state transition table where you mention the state. So your state is like we will mention all the states. So if this is your system, this is how the system is, or the system will move from one place to another. Imagine that there is something like this. There's a login, And then what would happen if you enter a correct password for the first time? It would give you access to the page. So we will make a state S1, which is first attempt. So first attempt, you would try to have like correct password, and then if you have incorrect password, what it would do. So with the correct password, it would give you access to the home page, but with incorrect, it will take you to the next stage, which is second attempt. So again, you would write one more test to second attempt. S2 is, so there'll be one more stage, second attempt, and you would try to have, so you would make all states here. So you will make a table with all the states. So you'll say first attempt, second attempt, third attempt, and then you will say home page, and then you will say log the account. So all the 5 different combination, what could happen in the system, you would put it all with the state, and then you will say how it will transition from one state to another. So state 1, if you have correct password, it will go to S4. So it went to home. So home, we have made a state, right? So S4, it will go here. But if you have incorrect password, which state will it go? It will go to state 2. So S2. So which is like here. So what you do is, let me, where is paint? Not paint, okay, hold on. Copy. Paste. Open. I can do this. So what my first part would be to make this diagram. So what are the different states? So, and then label it. So I make it S1, S2, S3, S4, and then S5, right? These are my different states. So I'll make a table. I'll first note down all the states, write what each does. So for login, what is the functionality we are testing? We are testing like login functionality. So first we will write like what is the state 1? It says first attempt. So I wrote it here. Second, which says second attempt. So I wrote this here. Third would say third attempt. I wrote this in the login. Fourth, this says homepage, which is like a past scenario. So hence it's written in green color here. And the third one is logged account. Again, one of the functionality which you have to test. So I wrote that here. So now how do we transition from one state to another, right? So from S1, I can either go to S2 or go to S4. So how do I do it? If I, and what is my input to go to this part, and what is my input to go to this part? So if my input is like password, if I enter a correct password, I go to S4. If I enter an incorrect password, I go to S2. So this is the first. So this is like first transition. So from this place, I can go to this one or this one. So that transition is done. So next time, if I'm here, there's nothing more to do. I mean, that's the end of functionality. But if I'm here, if I'm in S2, I still can go to places. So if I'm at S2, if I enter an incorrect password, I will go to S3. But if I enter a correct password, I'll go to S4. So either S3 or S4. Similarly, third attempt, we can go to S4 or S5. So from second, if or like third attempt, if we enter correct password, we'll go here. If incorrect, we'll go here. So this is, and how, and S4 and S5, there is no transition. So you can't go anywhere. This is the final. You see the arrow mark? It's coming towards it. It's not leaving anywhere. So this is the final state for them. There won't be any state for these guys. So it's nothing. And this diagram, either you have to make it. How would you make it? By knowing the requirements of the system. So for this particular case, I knew that that there's an application where you enter the password. You can enter password only 3 times. If you have entered password third time, your account gets logged. And if you have entered, you will get like 3 attempts to enter the password to successfully gain the access, or else your account will be locked. So this was the requirement. I had to first design all these states and then say how transition will happen from one state to another. But again, in real life scenarios, the transitions like this would only be for logins, and the other functionality or other things when you're testing, it will be like very simple kind of state transition. So it will just go from one page to another depending on the scenario. But why are we going through this is like you should think in your head about the different possible outcomes of the workflow or of an application. So how do you move from one page to another? So like the state will be transition. So once you get an access, this is one way to visualize your testing. Okay. Any doubts in this?
No.
Okay. Thanks for confirming. So we are good with this. Let me check. State transition is again a black box testing. System stays in finite state for a long period of time. You might get different output even when testing with the same input parameters. For example, banking machine. So banking machine, yeah. So if for this use for this testing or like this explanation, imagine that this functionality which we have discussed is like login into an application or login into an ATM machine where you put your card, try to enter your password 3 times incorrect, and your account would get logged. Or if you enter your password correct, it would take you to the home page where you can do a withdrawal of money. So these are like the different state transitions. So that's it. So we have discussed all the state transitioning. Now let's move to use case. Before moving to use case, let's take 5 minutes break and then we will go here. We'll come up with a fresh mind and then we'll start this. Okay?
Okay.
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 Thanks, guys. So we'll be back by 12:10. Is that fine for everyone? Right now it's 12:08.
Yes.
Yeah, it is. Thank you.
Okay.
Yeah, sounds good.
Let's have some coffee, some tea, and then come back. Okay. I hope everything is clear up until now. I'm giving some extra time to this topic, understanding that, understanding that it is kind of delaying our today's schedule, but this is very important topic, guys. So I don't want to skip this without everyone being on same page of understanding level. Okay. So let's take some break and then come back. See you guys. Hello. Do we have everyone?
Yes, I'm
I'm
here.
here.
Do we have Tommy? We'll wait for like 2 minutes for Tommy to come. So Tommy, as soon as you join, let us know. Do we have any messages? Yeah. Static analysis. Okay. Let's clear everything before lunch. We'll finish 2 hours. Let me open the same document which I closed. Let's say distribution table here. Let's see. Here. So Adi and Anselm, what do you think about all the 3 techniques which we learned? Are you clear about those concepts?
Yes. Yeah.
Yeah. So far.
Okay, that's perfect. You feel confident about it? And also, like, I want some feedback on like the way I'm teaching. Do you want it to be less descriptive, or is it going good so far? A little bit feedback on those aspects will be helpful for me, and it will help me to prepare in like for future classes. So not right now, even if you can give me through an email, it's perfect. So I can I will take those feedbacks positively and try to work towards it. Okay. No problem on that.
All right. Yeah.
No problem. Sounds good.
Okay. I think, okay, she's back. Okay, looks good. So let's start. So for use case, why do we need use case? The first question is, so with the help of use case, we kind of, it helps us decide on how we are going to test a system, right? The first thing is to test a system. So first, we will try to understand what we are going to test. So what are the number of users involved? First thing, what are different steps which we take to test a functionality of an application? And to do that, we kind of first write test cases with the help of test steps. And how do we do it? So how do we write these tests and the steps, test steps? We will study it in, or like we will try to go or understand in this section of use case. So for understanding this, one of the use case example, we'll take one of the scenarios, which is let's go over this use case, which is present by Busy QA. So let's go over this scenario. So here there are actors, which is customer and a bank. So customer could be any one of us, and then bank is a financial institute. So there are two people, customer and a bank. And the description here it says this use case describes how the customer uses ATM system to withdraw cash from his or her bank account. Okay, so how a person go, it's like a simple case where you go into an ATM. What do you do? What are the steps which you do in order to withdraw cash from your bank account? Okay, so for every use case or like every functionality, there is something called precondition. So precondition is very important thing. In order to test a functionality, you have to make sure that all the preconditions are met. If the preconditions are not met, you can't test the functionality. So here you're trying to withdraw money from ATM, right? So the preconditions are make sure the ATM is online. So that means the ATM is present, plus it's connected to the bank and the server, right? And the second one says like ATM should have sufficient cash balance. If you don't have cash balance, then you will not be able to, withdraw anything. So those are the preconditions. So every functionality would have some precondition. So like imagine you're trying to access an application just for like login purpose, right? So to log in into an application, what are the preconditions that you should be a user of the application, right? You should have a valid login ID and a password in order to use the front end. So what is that? That is like preconditions that you should have a user ID and password. So similarly, the precondition here is like it says that ATM should be present, ATM should have cash in order for you to withdraw. Then there is a normal workflow, and these are the normal workflow which says like the customer will insert their. So how would a customer take money from the account? So that is one of the normal workflow. So here is like customer will insert the debit card, system will prompt for PIN, customer will enter the PIN, system will display the option to withdraw cash. The customer will select the option to withdraw cash. System will prompt for an amount. Customer will enter an amount. System will submit the amount for bank approval. Bank will confirm the transaction and system will dispense the cash amount. So this is normal workflow. As in like what you would do. You would go into a bank account, present your card, enter the PIN, say choose the option cash withdrawal, and then it will ask you to enter the amount. You enter the amount goes for approval, bank validates whether you have sufficient balance or not, and then it will give you the cash if you have, right? So this is normal workflow which we do in day-to-day life. But however, while doing the testing, you just don't have to concentrate on normal workflow. You should also concentrate on something called alternate workflow. What would happen if any of the steps while you are performing these steps, if something goes wrong? So you presented your card, system asked you for PIN, you entered incorrect PIN. What would happen? The system will return the card. The use case ends with a failure, right? With an invalid password. So that would happen in an alternate flow. So what happened on the step 3, where customer will enter the PIN, you entered an incorrect PIN. What would happen is it will not go through step 8 to 12. It will directly come to alternate flow, which is this one. The system will return the card and user ends with a failure message. Similarly, there are more conditions. The second one is if the amount is invalid, right? See additional business rules. So if an amount is invalid, what would happen? The system will display an error message and prompt for another amount. And so imagine you have only 2,000 in your account, you try to withdraw 4,000, system will display an error message and the use case will resume at step 7. So if you go back to this, then customer will enter the amount. So instead of exiting from the everything, it will again put you back into step 7. So it will not ask you to enter the PIN back, or it will not give you the card back, but it will just say enter some another amount in order to withdraw. So those are like the different workflows to test one functionality. And then if the bank declines the transaction, 10A. So here it says if a bank declines it, the system will return the card. The use case ends with a failure. So this is also one of the scenario when bank declines the transaction. And third, if the customer selects option to cancel, the system will return the card. The use case ends. Or there's one more condition like in 10. So the condition is 10A if the bank declines the. So if a bank declines the transaction where it says 10A, 3A, 5A, 7A. Let me see what this 3A, 5A, 7A means. I don't know what this A means here, but yeah, the only thing is like these are like the alternate flows, what bank will do when either incorrect pin is entered, if there is more if there's more amount if we try to enter the amount which is more than the balance, then what flow it will have, plus if bank declines the transaction, what flow it will have, if customer selects cancel option, what flow it will take. So these are the different cases which for this functionality, and this is one of the use case, and these are the different workflows and steps. So now we have to write like a test case to test all these. One is like the normal flow. We have to write test case to make sure the alternate flow is tested. We have to make test case to make sure this this part is tested, which is like if we enter an invalid amount. So we have to write test cases for checking all these functionalities. So like normal flow, alternate flow, and alternate flow also has like different versions. One is like invalid pin, system entering more amount, you press cancel button, bank declines a transaction, something like that. So how do we write it? So let's go with the normal workflow first. What we would do is like we'll write test case, we'll write steps, we write expected results, right? And how it would happen. The first one is like cash withdrawal. So for every step which we do, right, there will be an expected results which system will give. So test case one, you're testing the normal flow. So let's write it. So test case. Test case one, we are testing here. What we are testing is normal flow. And we know that for every test case, we have steps and we have expected results. Right. So first we are trying to test application where we are testing. So I'll keep this open on my side. Where's my snipping tool? Okay. So that we can see. I hope you guys can see my screen, right?
Yes.
Okay. Okay. So let's see what it says here. So first it says we are going to test the normal scenario. The normal scenarios has test case. So first one is, what is the normal scenario? The customer will insert their debit card. So my first step would be to insert debit card. And once you insert the debit card, you are expecting system to respond. So expected result is system will prompt for pin, right? That's what system will do, just to make sure that this does not take a lot of space and we see everything in one page. Okay. So this is kind of step 2 where you enter valid PIN. And what will your system do? Customer will enter the PIN. So this is done, and the system will display the option to withdraw cash. So system will display to display the option to withdraw cash. And what do you do in step 3? Customer will select the option. So it's like what you are doing here and what system is doing in expected results. So what you're doing now, customer will select option to withdraw. So here it will say select the option to withdraw. And what will expected result? What will system say is like system will prompt to enter. The system will prompt to enter an amount. Okay, so that will happen. So once system tells you to enter the prompt, what you would do is so this is done, the customer here. So customer will then customer will enter an amount, valid amount. So maybe like $100. And what system will do is system will dispense the cash and return the card. So system will then dispense the cash and return the card. Let me wrap it. Okay. So this is like the normal flow. What would happen in the scenarios where we try to write the test case for this. So what is the test case? This is the test case 1. It has like 4 steps. In this 4 steps, you have like some actions which you would do as a user, and you will have a system's response for every action. There's a system's response. So this is what it's going to do. So this is if all the steps are passed, if all the steps what you have done, like you inserted debit card, it prompted you for PIN. So if all these steps are passed, that means your test case is complete. That means you have successfully tested the normal workflow, right? And this will be one of your test case. So in this scenario, you have tested the normal workflow, everything is fine. And now your use case describes a new or alternate workflow. So for that, you would be writing test case number 2, 3, 4, so something like that. So for this, I'll close this. And let's go to the alternate flow. Let's see an alternate flow. Let's name it test case 2, where now we are trying to see the alternate flow, which is this part. We will be writing test case to test this. We have already written test case to test all this complete functionality, which is here. So now we'll be testing the alternate flow. So what we would do? So here we will try to do a cash withdrawal with incorrect PIN. So we already know with the help of if we enter incorrect PIN, what it should do, it should just it should return the card and user ends with the failure and use case ends with the failure, right? So this will be like a negative test case, but it's not like exactly negative test case. It's just like since it's since we are testing negative or like alternate flow, it's still a positive because like this is required for the system. This is how system should behave. So this is still a positive test case. So what you would do is you would have same this one. Well, not and insert debit card. System will prompt for PIN, enter invalid PIN. And what will system do? System will return the card, and that's it. Your transaction is complete. So you have tested the main workflow, which is normal. You have tested the incorrect PIN. Now let's test what if amount is invalid. So here it's a little bit tricky because it is sending you back in the normal flow. So you would do 1, 2, 3, 4, 5, 6, and 7. So after 7, system instead of going for bank approval, since your amount is too much, it will send you back to 7. So system is sending you back to 7. What did it do here in this invalid PIN scenario? It just after step 4, where it's like customer will enter the PIN, system will display option to. So right after this point in our previous test case, system kind of closed it. So normal workflow, all these steps were not executed. It went into an alternative and it kind of returned the card and it went into this alternate flow. So that happened. But now in the new scenario where the amount is invalid, what it would do is let's see what it does. I'll just copy paste, select the amount. So instead of, yeah, let me just copy it back. No worries. Just copy paste. So test case 3, it's instead of normal flow, it's cash withdrawal with invalid amount, right? We are trying to do something which is not valid. So again, you have to follow the same step, which is like insert debit card, insert valid PIN, insert debit card, enter valid PIN, select the option to withdraw, enter and then instead of entering 100, make an amount which is more than what you have in your account. So you can also enter 0, right? This is one of the case where you try to enter 0. When you try to enter some money like 101, again for 101 it should not let you because ATM can't dispense in 1, 2, 3, 4. It should just be multiple of 10 or 5, and then so you try like 0, it will return you back saying that there's and they'll ask you to enter like the amount again. Plus if you do 101 or like even if you try to do $1. So for all these cases, it should send it back. And sometimes even when you have balance insufficient, if you ask for more money, more than your account has, so insufficient. So these are like the different tests which you will be doing this step. So you will try for like different input types. So let me put sorry, so that we can see it in one screen. Okay, perfect. So you're trying to customer will enter an amount. It could be 0, 1, 0, 1, 1 or integer. So if you have any of these inputs, then what system will do is system will display an error. System will display error message and prompt for another amount, which is mentioned here, right? What we see in this case is that instead of exiting from the scenario, we will keep running into the same scenario until a proper amount is chosen. So instead of doing it in one shot, we can also break this part down into multiple steps. So we can write it here and say, first you tried with $0, then you tried with $101, then you tried with $1, and then you tried with insufficient fund. And in all cases, your application should send you back to same step. That way you would test all these various amounts and make sure that your workflow is working fine, right? And this, you have to validate the system state after every input you enter. So all these 4 states you have to validate. So this is how a test case is written. This is how you interpret a workflow. You make sure that each and every workflow, or yeah, this is like a workflow. So you have to make sure the normal workflow is covered in your test case. You have to make sure alternate workflows are covered in your test case. So in our case, like normal workflow, alternate workflow, and even if there is more, you have to make sure all the alternate workflows are covered, not just one. Okay, any questions on this, on how the test case would be, or what we would be testing in workflows, and what is use case? Use case is nothing but the entire functionality which you're going to test. So for our example, we took a use case where banking application was considered, or like a ATM is considered from where a customer can withdraw money. So that was our use case, but this is the functionality which use case is doing. So similarly, in real-time scenario, you will have functionalities like this, where you have to test like main workflow should be working fine. You have to make sure that alternate workflows are working fine. So this will make, this will give you the confidence that, okay, all these scenarios are properly programmed and is working, and the application can be sent further for deployment and for people's use. But imagine if someone didn't test this, if someone didn't test this invalid amount scenario. So every time they enter one, the system, every time they try to enter 101, what would system do? If this was not tested or developed, how would system dispense 101? So maybe system would display $100, or system would display $200. So in those scenarios, like there's a loss for bank and stuff like that. So that's why we have to make sure that before things goes into production, we test each and every other scenarios into of the application could go into and test them. Any questions with the test case, or the approach we should take while writing the test cases, or we are good?
All good.
All good, perfect. So let's move on to the next topic. I'll save all this. I'll try to insert the use case also. Okay. Next is static analysis. Okay, this is very good topic. And static analysis. So this is like, how do we test an application on the verification? Remember V model, we studied like verification, and then we studied like validation. So we studied verification and we studied validation. All these, where we had like requirements on the left side, And on the right side, we had like acceptance testing. Then we had system testing. Acceptance testing, system testing. Can I write it from my hand? Acceptance testing and integration testing. Oh wow, integration testing. And here we have unit testing. And here we have requirement analysis. And then we have on this side, what else do we have? Then we have design. And then we have requirement, design. Then we have, what did we miss here, guys? Any idea? There's one more thing. So we did requirement analysis, we did the design. What else did we miss? Can anyone say from the last class?
The development.
Okay, perfect. So development is here in these two stages. So coding. So coding is kind of done in this one more, but there's one more thing here.
Module design.
Okay, so design is the second part. Requirements is first. So it is detailed design, but I don't like this one. I like the other one which we discussed. Oh, that's correct. It's module design and then body. Yeah. This is high level design and Tommy is right. This is module design. Module design and here it's coding. Okay. So everything what we do here, this is verification. As a testing, what can you do in these phases? You would just go through the documents, all these documents, and try to find problems in the document, in the requirements or design or module or whatever. So what this type of testing is called is like static testing. So you would be doing these testing by reviewing the document or by going through walkthrough or through inspection. So let's see what all these things mean. So you would not execute any code. You would not execute the application. You will just go through the document. So it's no execution, just reviewing the documents. What is walkthrough? What is technical review? What is inspection? So walkthrough is done with, so what in walkthrough, a BA or business analyst at the starting of the project, after completely writing the business requirements, getting it approved and reviewed and whatever, after completing the BA part, they would do a meeting with team as in development team and testing team, where they will walk us through the BRD document, which says like, what are the different functionalities they are going to get into or they are trying to be developing in the next stage. So that is first part. And then they will take us through the entire document as in all the functionalities which are being added. Then they will ask us for our inputs as a developer and also as a tester on like they accept the feedbacks. They in the walkthrough they will also clarify your questions on any functionality or on any questions which we have on functionality. So the walkthroughs are done by business analysts, and this is done just for us to have an idea on what the project is all about. The second is technical review. What happens in technical review is this one is done by developers. So what developers would do is like they would design so after walkthrough is done, they would get the BRD document, they would design the document, they would design some solution, they will start writing the code. And in technical review, they will say that how they have designed the application, so here in this one, they will go deep into the design of the application. So they will say that they have designed some tables, they have designed some UI screens and stuff like that. And then and we would be going through those review documents to find some issues with the design and things like that. So like those part would be done as part of review. So here you're not executing anything, you'll just have a document, you will read the document, you would attend the meeting, you would ask questions, and if there's any issues, you will tell the respective team to fix this. And the final is inspection. Now in inspection, what you're doing is you're going in walkthrough, you were in the meeting, in technical review also you were in a meeting. In inspection, you will have all these documents in your hand. You will go through it line by line and review it. Review every part of the document, make sure all the functionalities are covered, and it's making sense logically. And if you find that there is some problem, you report it. So that happens. So you're not executing in static analysis, you're just reviewing. So this is one of the important, what do you say? This is one of the important topics, or even in interview, I have been asked a couple of times, like, what is static analysis? So where you just have to mention that you verify the documents without executing any program or code, try to find bugs in the design or in the documents by doing inspection, by doing walkthrough, by doing technical reviews. Okay. And find the different types of defects, which is like deviation from standards, missing requirements, design defect, non-maintainable code. So like how I mentioned earlier, that what do you do after you, what kind of defects are you looking into it? You're making sure that all the standards are met. And if something is missing, like if there are some requirements missing in technical review or like technical specification document from business requirement document, then you highlight those. And then if there's a design defect which you have identified, highlight those. And if there is non-maintainable code, you have to highlight those. So like you're kind of highlighting all the issues which you face in the documents. And this can be started early, like how I said, in the RV model. So let's go back to our V model. I think I closed it. So in our V model, after, so what we did is like, as soon as we had our requirements document, we would start writing acceptance testing, right? So we would have all the documents, so we can directly, as soon as the document is released, we can go and do these parts, or like inspection or static analysis. And then there's a static analysis tool as well, which is not as in tool, there's a metrics to so this cyclomatic complexity matrix. What this does is like it tells if our testing is completely done or not. So this is not a analysis as in like you will not be just going through the code or doing this, or like you will not be going through the document and doing this. This is like the coding level. So coding as in like this is mostly used by like the developers who would be doing the testing. So what happens here? So now let me introduce something called flowchart. I have no idea. Does anyone know what is flowchart?
I think it's like a graphical design showing the process, like a process of a outcome.
Yeah, so that's true. So it's like a process, or so flowchart is nothing but a process or like steps a process would be taking from starting till ending. So this is one of a programmatical flowchart, not like as in it is not a workflow process, but it's like a program. So like when you try to write a program, like which we would discuss from like our week 4 or week 5, I think week 4 classes. So what steps are we taking? And like, so this is one of the flowchart of one simple program where the start, where this indicates the start of the program, where this indicates that there's a variable being assigned, and then this is like a decision box where it says like all decision has like a condition. Decision means like either this or that, right? So this decision is called if statement. I will explain this more when we get into programming part, but for now, just think of it like a decision box. It's like there's a person who is deciding based on some condition. So here, if B is greater than C, it would decide to go here. If this is true, if it is false, then it would decide to go here. The flow will decide to go here. And then what it does here is like it assigns B to A and A to C. So this is nothing but a flow chart which tells system that if B is greater than C, then assign value of B to A, and if B is less than C, assign the value of C to A, and then finally print ABC. So this program is doing that. And now why are we learning about this? In order to understand the cyclomatic complexity, which tells, okay, so before even going into cyclomatic complexity, let me tell you something more. So at this point, there's this developer who writes code, right? And while they write code, they would be writing, so they will be kind of converting this workflow into a code. So this is like a workflow which they will convert into the code. So your code will have like a starter. So like how the main execution, from where the main execution will flow. So it will have like a main from where the flow will start. Then it will have like operations which it would do, and finally it will have the output. So it will have like operation, and then it will have like output. So operations could be like this one, like assigning a value to a variable or making a decision and stuff like that. So here, if you see, a flow can take two direction. One is like it will come here, the flow will take this one, and the another one is like it will start here and the flow could take this one. There are two flows. So for unit testing, developer, when they write their code, they have to make sure that they test in the unit testing, they test each and every component of their code. So whatever they are writing, they load like 100 lines of code, right? So they have to make sure that all the 100 lines of code is executed once. They have to make sure that all the 100 lines is executed once. That is called. So unit testing is done in, so unit testing, we will learn more about unit testing soon, but here I just wanted to give a brief ideology of what cyclomatic complexity is. But before even going into cyclomatic complexity or this coding part, we would first want to understand what this or why do we even need it. So unit testing is done by development. So development team would write the code. After writing the code, they would execute their code and then they would validate the output, right? So how do they have to do it? So first they have to make sure that all the conditions or all the statements which they wrote on the code has to be tested. Okay, so all the statements should be executed one time. All the conditions has to be executed. So statement is first, second is condition, third one is all the path has to be covered, right? So testing a condition is like just test if this is working or fine. But now the second is you have to make sure both this path plus this path has been tested. So that is as part of unit testing. So make sure both the path is covered. And then if there is loop, make sure all the loop is executed once at least. And that way, so we have kind of covered like statement, we have kind of covered like paths, we have covered loops. I think we have covered almost everything. So that way we would know that, we didn't miss anything. So that is part of unit testing. So to do that, there's a concept called cyclomatic complexity, and we have to use some formula to calculate the complexity. If you're not understanding what this A equals to 10 or yes or this or A equals to B equals to C or whatever this flow chart means right now, don't worry. Once we get into coding, you would understand this part clearly that time. because right now you don't know what is condition, what is processing, as in like what step is happening here, plus what is start, what is stop. So those things will make more sense once we get into programming. But for time being, just understand that all this flowchart gets converted directly into programming, where like for each and every aspect here in the diagram, there is a code. There's a single line of code or multiple line of codes to represent each and every point in this flowchart. And as a developer, as a unit tester, they have to make sure that each and every line in the code is tested, each and every statement, as in like how we write. So like for this one, we would be writing like if B is less than C, then perform something. If B is greater than C, then perform. So if there's an if and else condition, so that will be that we will be executing. So things like that. So we are covered with unit testing. Now coming back to complexity, cyclomatic complexity. So it is nothing but determining the independent path execution, thus proven to be very helpful for developers and testers. And then it will make sure that every path has been tested. So make sure every path has been tested. And then it will help. And why do we do this? Because it will help to imagine a developer has just tested this part and forgot this part, and there is an issue in this path, completely this path. Then it will not be discovered by developer. But however, when it comes to testing, it will be discovered. So it's also said for developer that make sure that you test all the paths of your unit while doing your unit code, and make sure that the code coverage or the test coverage is high by doing this. And there's a metrics which can be identified, which has a formula of cyclomatic complexity is find number of node. So here is number of nodes. So how many nodes we have? We have 1, we have 2, we have 3, 4, 5, 6, and 7. So find the number of nodes. We can say find number of nodes, then find number of events, and then we have the final thing we have is, or events, no, these are like edges. So these are like the edges. So all these arrow marks are like the edges. So we have like 7 nodes in this diagram, and we have like 7 edges. If you see 1, 2, 3, 4, 5, 6, and 7. So we have 7 edges and 7 nodes. So 7 nodes, 7 edges, and then finally the formula for it. Uh-oh, what happened? Control Z. Let me write it in a notepad. Make a new notepad. Okay. Cyclomatic complexity. So the formula of this is number of nodes minus number of edges plus number of plus 2 times path. So for our case, we have 7 nodes, we have 7 edges, and we have 2 paths, right? So our complexity, cyclomatic complexity will be 2. So this is the formula to find out the complexity, cyclomatic complexity. And This is for the diagram which we saw here. I can make a new one so that we are aware of it. So it's simple. It has like 7 nodes, as in each and every thing here is node. So 1, 2, 3, 4, 5, 6, and 7. 7 nodes, plus we have 1, 2, 3, 4, 5, 6, 7 edges, and we have one path from here, and we have one path from here. So to imagine that there was one more thing here. So like instead of this, if there was one more decision table, right? And it would come like this, plus it would have one more thing here as an. So it would have in total one path as in like extremely like this, and one path from here, and then this has one path. So it would have like 3 paths, plus it would have 1, 2 more. So it will have like 8 edges, 8 nodes, and 3 paths in that case, and our complexity would change. So if we have like 8 nodes, 8 paths, and 8 node, 8 edges, and 3 paths. So our complexity will then be like 3. There are cases when these two numbers will not match, and then your complexity will go up. Okay, any problem understanding cyclomatic complexity, why we do it and how we do it?
No questions from my side.
Okay, perfect. Nice. So we can go ahead with the test cycle. Okay, now this is very interesting. The final topic of this module, and which is what are different types of testing? We'll all be asked this in like various places, all interviews, and it's also required for yourself. Like while testing any application, you have to make sure that all these different parts are kind of considered. So let's start with unit testing. So unit testing is done by developers. So what developers would do is write, they like how I explained you earlier, that there's a functionality which developers will break it into small modules, and like even just a while ago, even Tommy mentioned that developers will be doing their module design. So every module will be designed and then coded. So after module is coded, for every module, developers will be doing a unit testing. So for every module they wrote, they will test it, whether it's working as per their design or not. So once they do it, they will integrate two different modules and make sure that the integration is working fine or not. Okay, that is what. So unit testing is completely done by developers. This test is usually done. It's more focused on elements or functionals which developer has coded, and it does. So unit testing, developer would not test like the entire workflow. They will just test small modules what they have developed. Okay, and now as a part of functionality testing, has like 3 parts, which is like system integration testing, system end-to-end testing, and regression testing. So all these 3 parts would come as like a functional testing. So what happens in integration testing is like different modules are combined with each other in integration testing, and they are tested. So like value from one module is given to the second module, and second module will take the values from the first, and then it will calculate, and then how is this integration working? Are they working fine or not? So the different modules, how they interact with each other, that is what we do it in integration testing. However, system testing is like complete system testing. So imagine your banking application, right? You log in, or like ATM withdrawal. So system testing in ATM withdrawal will be like a customer goes, inserts the card, puts the pin, enters the amount, gets the output or gets the cash. So that's like complete workflow. So from end till end. So you're checking and testing all system components. So like this is one of the use case example I gave you, but imagine that there's a bigger or wider application where, or like you even take like Facebook as an example. So you can log in, you can do a post, you can see other different user stories, and then you can send friend requests, you can accept friend requests, you can do messaging. So all the functionality in complete is called end-to-end testing, where you test each and every single functionality of an application and make sure that it's working fine or not. So that comes under like system end-to-end testing, or sometimes it's also called as integration testing of different systems. The third is regression testing. So what happens in regression testing is, this is very important. So imagine we are testing a functionality, given a functionality where, let's take an example as again banking application, right? Where you can log in into the system with valid email password, or like valid PIN number. You try to enter an amount, you try to withdraw the money, and even though your bank has sufficient balance, your ATM has sufficient balance, the still money is not being dispensed. So that is like a defect. So you will say that, okay, I tried to test this functionality, it's not working. You will log a defect. Defect will go to developer. Developer will fix the code. They will do their unit testing, make sure that functionality is working. And now developer has given you the new code. Now, when you go to test the application, you put your ATM card, you enter the password, you enter the amount, which is sufficient balance and sufficient balance in both your account, plus it has the ATM also has balance. ATM will dispense the money. But this functionality is fixed. But while doing some changes, the developer kind of messed up with the other part of the code, which is around this area, right? And that part of the code is broken, but you have not tested it because you tested it earlier and it was working fine, but now developers have changed a code, and that kind of introduced a new bug. New bug as in like, now when user enters $100, they get like uh, $50 back instead of $100. So this is like a new introduction of bug. So how would you discover such issues? Or like imagine like another functionality could be that enter even though user enters invalid password or PIN, still user could log in. So this is a new bug which was introduced. How would you catch these bugs? Which is by doing regression testing, which is like testing the functionalities which were working before. So how would you do that? So every time a developer makes a change in the code and sends the code to us or delivers the code for us for testing. So we not only test the defect which they fixed, we also test another functionalities of the project, and that is as part of regression testing. The regression testing happens in two phases. One is like if a defect is fixed, and we test like the defect plus we test other functionality, what is in regression testing. Second time we do regression testing, which is very widely done in majority of the system, is imagine we are following a agile methodology or waterfall, anything. So first phase of project development is completed, right? And now we have a code which is working fine, and we enter into next phase where we are adding more functionalities to our software. So imagine like there's a application for which we have already built like login page, we have already built like customer information collection page, we have already built like messaging features, and it's all working fine. Everything is done. It's already in market. Everyone are using. Perfect. Now business comes and tells, okay, you know what? I want to add new feature to the application, which is like with this application now I can sell uh sell some, like imagine like Facebook market. So we can sell something in this in the market with the help of this functionality. So what developers will do, developers will make a additional web page into the same application, and now that can be used for uh, marketing or selling products. However, when it comes to the testing, we will test all the new functionality, which is 100%. We have to test all the new functionality, but we will run regression testing for all the existing functionalities, which is like logging to the application, whatever the functionalities which were existing before. So regression testing, again, now someone could ask me like, regression testing, we have to run all the test cases? No, we don't have to run all the test cases. So all the test lead or team members or anyone would identify important test cases from the test suite and put it or mark it as regression testing. So what happens is like when we are entering into the next phase from one phase, so all these regression testing cases would be moved to the next phase where when a functionality is developed or delivered a new functionality. So new functionality will be tested anyways, but we run a regression testing or execute the test cases present in regression suite to make sure nothing from previous working functionality is broken. Okay, so that is regression testing. Any doubts on regression testing?
No.
No.
Perfect. Now moving to performance testing. What is performance testing? What do you feel like? What could be performance testing? Any example? Because it has the word performance in it, so anyone could take a guess. You could be wrong, but that's fine.
Maybe maybe testing the app to see if it's efficient.
Yeah,
That's to see how well it does whatever function it's supposed to do.
that's true. But performance is also on the parts, like the performance would be, imagine you're using an application, right? And you try to log in and it takes 3 or 4 seconds to log in. You're fine with it. But what if sometime when you try to log in, it takes 10 seconds? That means you are waiting for 10 seconds. Right now, if there's an application which does not work for like 2 seconds, you will be like, wow, this is there's so much latency. It does not work. It does not load up, things like that. So those things are performance. Performance as in like the user experience. Functionality is working fine. That means login is working fine, but it's taking time to log in. So that is performance. Plus, so this is one of the thing, which is like the response which you get from system, it's late, it's delayed. The second is uh, number of users which can log in. So every application has like some limit. So you say like 10 people can log in at a time. So when the 11th person tries to log in, they would not be able to log in, right? So performance, you have to also test that. Then how many requests can be sent at the same time into an application? So that is one more. So all these parts of testing, which is like where you're testing the response time, where you're testing uh, if the system is working fine with more number of users present at the system or like logged in under the system, and still system should be performing better. So those things. So imagine like there would be some application which would crash. I remember one of the application which is like during COVID, when the first when the during COVID when the application or the web page launched to get your flu shots, there were like millions of users trying to log in into the page and trying to book the slots for their first vaccine shot. So system on the first day wasn't designed to handle that amount of load, that number of users. What happened is the system crashed. Like people could not log in and do the work they wanted to. So they could not book the slot. So that kind of costed like, problem. So how could this be achieved? By doing some performance testing, which is like make sure that even if 1 million people tries to log in, it would let them log in, or define a state that, okay, there are some system where like 100 people can log in together. So when 101th user goes to log in, it would display a message saying that there are too many people using this system. Please try again later. So something like that. So that is like a good message which it would send to the user rather than crashing the website, right? So that is one of it. So those are like performance testing. Then another aspect of it is user acceptance testing. What happens in user acceptance testing is like, I think I have explained this in previous session, where this testing is done by users, as in like either it could be a business user, or like business user as in like the UAT team. UAT team is user acceptance testing team, could be from business analyst team also sometimes. And so user acceptance testing is done by two phases. One is like alpha and one is like beta. So alpha are the people from the same organization who would be testing the application and trying to break it. It would not be anyone from QA team or the project. It can be from other teams also, but they would be from the same organization. So imagine like Facebook, there are like so like in Facebook, there would be a team who would be working into some different application and not Facebook. So they will become like a UAT tester for alpha level. So they are working for Facebook, but they are not working for this project of Facebook, as in like Facebook application. So those will be like alpha users. And then once they are satisfied, then the application will go to the next level, which is like beta testing, which is common users of the application like us. So we don't generally opt for beta versions, but there are some people who are like very interested in kind of knowing more about the new technologies and new things which are coming into the market or new releases. So they would try to use that application. Even our phones, like imagine I'm using iOS right now. So iOS also has like a beta version, but you need to know how to hack your phone and jailbreak it and then use it. But for Androids and all, there's a beta version. People download it from their website, try to load it into their phone, try to use it, find some problems, report it to people and things like that. So that is as part of beta testing, where application would go for first level of user experience testing. And here people would test like if application is working fine, if they are trying, and the motive for user acceptance testing would be um, to see if the application is easy to use and they're understanding the reason why the application was built and things like that. I hope I'm clear with all these topics. Now going to smoke or sanity testing. So these are like two things which it's not like same thing. So smoke testing. Why do we do smoke testing? Like, what do you feel? Well, this is like actually difficult to say, but let's say, uh, uh, what do you think? Like when you hear about smoke testing, what does this put in your mind? If there's no guess, that's fine, because even when I was trying to learn this, I would have no idea about what the smoke testing was. So that's fine. Any guess or no? I
Smoke.
Sorry.
I feel smoke detection or smoke maybe like it should bring out if like the effects of the box. I don't know. I'm just saying no. I don't know. It's just
I thought someone would say like, I'll smoke and
smoke.
then test stuff. Well, this is what I was thinking when I first heard about this word. Like smoke testing, what? Like people would smoke and test, or what is this? Or
So
does
it's
have
something that is not real.
no sense about this words at all. But the point of smoke testing is when application is developed, right? And it's sent to the testing team to test. We would first, as a tester, we would first do smoke testing instead of directly going and jumping into the application, testing everything, uh, and starting to test everything uh, without making one complete flow. So we'll directly, if we directly jump into testing all the functionalities. So first we will try to test all the basic functionalities, right? And we will try to execute the test cases. But there could be a problem with the workflow, with the with a complete testing of the workflow. So to avoid those problems, what we do is we do a smoke test. What happens in smoke test is like application comes to the testing team uh, starts to test. And what they would test is they will try to do one complete flow. One complete flow, as in like they will log in into application, they would create their profile, and they would for a banking application, imagine they will log into an application, they would do a deposit into the application and make sure that the deposit is present into the system. So one full complete workflow to just make sure that application is working fine. What if you try to log in and the login does not work? So that is like a problem. When you try to install an application does not get installed in your mobile. That is an application issue. So we do a smoke testing to make sure that okay, we receive the application, the basic check is complete, and it's working fine. So basic test, as in like you don't have to be very descriptive or anything. Just make sure that the basic workflow is working fine. That means uh this so what smoke here means is like if you so smoke is like if you blow a smoke, then it should pass from one system or like start of the system till end of the system completely. So that's what it means. So one test is so basic flow is working fine. You have to test that. So that is smoke testing or sanity testing. So I hope smoke testing is clear. So done by testing team. As soon as the application is developed, given to us, we will check a basic workflow is working fine or not. Right? We won't do extensive testing. Even if you like try to deposit $100 in your account and your account shows $1,000, that's fine. Your smoke testing is complete. Smoke testing says that application is accessible. Application has the workflow which was designed for this as part of this development cycle, and it is all the new units are present and it's working a little bit. It does not have to work completely. Even a little bit is fine. And after smoke test is complete, we would start the real testing. If smoke test fails, we would send back the application to developer. We'll tell fix it, make it into a state where we feel like okay, testing. If we do testing on this application, is going to save money and it will not waste our effort. That's what. I hope smoke testing is clear now. We'll move to next topic. Yes.
Yes.
Okay, perfect. So now is exploratory testing. Exploratory testing is my favorite. I love it because I don't have to follow any documents to test this. Exploratory testing is like you get the application, you open the application, you start testing everything and anything and how you feel like. So you have a functionality which is delivered to you. For example, let's take again the banking application. So your exploratory testing would be to just go into the application, normally log in, try to break the application however is possible. So try to do any crazy things you can. Try to enter $1 million as a deposit, $5 million as a deposit, and make sure that it's working fine. Make sure you try to enter some names and different various inputs you can do that. And exploratory testing, you would try to kind of find a bug earlier as in like before even executing a test cases. Many companies, like even my current company, we have exploratory testing. So as soon as the development is completed, right? Once we have the code, what we would do is we would do exploratory testing. What happens? What's the advantage of exploratory testing? Is like we will not be going through test cases or anything. We will go through business requirement document and go through each requirements or like each functionalities of the application, and then we will see okay, this functionality is working fine or not. So if the functionality is working fine, we will try to break the functionality, because in exploratory testing you're not documenting any test results, you're not documenting any or not making any notes of documents. So you're just trying to break the application and try to find defects earlier before it even reaches like the testing phase. So it is in testing phase, but like not the real test execution phase. It is like pre. Sometimes we call it like embedded testing. So what happens in embedded testing is like we won't be recording any test results. We will just be testing as much as possible. So this is done. First thing, to identify the defects earlier, and then second is like it has less or no documentation at all. And in this one, you don't follow any test case. So you use your uh, common sense, logic sense, and whatever mindset I was talking about, like a tester would have. So you would use all those techniques and try to break this functionality. And again, once you start testing an application, you would know, okay, there are some functionalities which every developers would make mistakes in. So you would know, as you gain experience, you would know, okay, these are the areas where developers would have 100% made errors. So you would test those areas first. So your exploratory testing, as you gain experience, it will improve. And then based on your experience, you would be testing those products or those areas which is like high prone of having defects, which is called like defect clustering. So those areas you would test first and make sure that you try to break those areas and then move to a smaller or like less defect finding area in the software testing. So are we clear about exploratory testing, smoke testing, regression, and all this one?
Yes.
So
Yes.
if on next Saturday, if I come back and I'll say, okay, Anselm, what is regression testing? You'll be able to explain me, right?
I believe so, yes.
Okay, perfect. Okay, that's good. Uh, I I think we are running a little bit late, which is like we are already at around 1:30. So I think, but however, this was very important. As a QA, you should know all these topics, so that's fine. I would say let's take a break of 5 more minutes or 10 minutes, and then we would meet back to study all these topics. This will take at least an hour to finish. If everyone is fine, we can meet like after 5 minutes and do like couple of topics from this and take a lunch break. Our lunch break around like 2:30 should be fine. If
Okay.
okay. Yeah.
Yeah.
Okay.
Yeah,
Let's do
yeah.
that. So let's meet in like 5-10 minutes. We'll discuss these two topics when take 30 minutes lunch break and see what we can cover. Okay.
All right.
So let's meet at like 1:35. Thank you. Hello.
Hi, Sri.
Hi, Tani. Nice. Everyone is here.
Yeah.
Nice. Generally on weekdays I don't talk so much. So when I come on these sessions, there's like 6 hours of like lots of talking. My jaw starts paining after a while. So I need to relax for 5 minutes. No, it's fine. But it's nice. I enjoy taking this session. Try to, be as descriptive as possible to make sure that everyone are understanding. I hope it's good. Okay. Now next topic is test execution and management. And this is very important topic. So today we are going to discuss let me bring up the documents first. Okay, so we are going to discuss on some documents which are of high priority, which is required in test cycle. So software development life cycle has like two parts, right? So first one is software development life cycle, where you have all the stages, including software testing. And then there is something called software testing lifecycle. So STLC, they say. What happens in software testing lifecycle? So software testing lifecycle is part of software development lifecycle. So like a small part. So um where so let me keep this as it is. So we have SDLC because we have BA, dev, and then test, and we have deployment, right? So this test is kind of expanded into software testing life cycle, right? And this testing life cycle has stage. First is like test planning, right? Then test scripting, where you write like test case scenarios and test cases. Then we have test execution, and we have defect life cycle, plus we have test slash exit report. So these are the components of test software testing lifecycle, and it follows this way. So test planning is done by QA lead or senior tester in team, right? And what they have to do is create a document called test plan document. We'll go more into what test plan document looks like, what are the different points in it and stuff like that in some time, like 2 minutes. Then once test plan document is made, it's got reviewed, signed off, then then it goes for the next one, which is like test scenario and test cases. And this can be done by like intermediate or junior QA, where they write like test cases. Okay, and then it's passed on for execution, where all the test cases written in part in all the test cases written earlier are executed. And if there's a bug identified, bug identification is done here. And after identifying what happens with bug, like this called bug life cycle or defect life cycle is followed, that we will see soon. And then finally we do exit or test report. So create a exit report for stakeholders. And these are for, this is done by QA team lead or even senior QA for state for QA managers and others. Right? So these are like different parts in software testing lifecycle. Let's jump into test planning. What happens in test planning? What are the documents? How the documents look like. So I have one example. I will try to send this document to you as well. I have it here. I'll be sending you this templates, which has like all different, as in like there is example of different requirement documents, and this is industry level documents. So these are being widely used templates, and you have some on like some very high level example or like real-time projects as an example for this. So do not share these documents with everyone, because it's you have paid a lot of money for this template. So I would suggest just keep it with yourself and do not share a lot with many people. Anyways, these documents are also readily available in internet, but not the same one, obviously. But the templates. But however, this one is like very well designed templates, and it has like an explanation, and it will also make you go through different scenarios or different projects. And you can have like you can have like an experience, but by going through the requirements document on all these different cases and plans, you will have more ideology, and it will make you feel like you have worked on lots of projects, like if you went through all of them. But for time being, and since we have done time constraint, we'll go through one where I would explain each and every topics in the document, so that after knowing that, you can go to any other document and most of the concept would remains the same. So this is I'll be sharing these documents with you if you don't have access to it, and so that you can study it. So for test plan, I have selected one of the document for the presentation. I'll show that. I think it's here. Okay. So there's one application called, or like there's a application for which this test plan was created. The project name is toll-free cloud application, and we will see what it does. So this is like a test plan document. How will this go up? Okay. So this is like a test plan document. And I will try to explain each and every topic in the test plan document, right? So let's go through it. So first one is like the document control and approval history, revision history. Approval history is like who approved this document and approval date, and then revision history as in like first initial draft was made, who made the draft, I mean like who changed it, and when was the first draft done, plus it has like the versioning number, so what version it is right now. And for each and every version, there would be one entry here, and who changed it and what was changed, summary of change will say those. So this revision history and stuff like, and these headings are same in other documents also, which you would have gone through in daily life cycle. So even the document ID, document sensitivity level. So these are like the important aspects of test plan, where all this information has to be noted and be present in the test plan. So document ID, document sensitivity, you would also see like some projects are very confidential, then it would have like a watermark saying confidential, and some documents will say internal. So that means like it should be used within the organization, it should not be shared outside. Or if you do it, then there will be some security or consequences or legal consequences you have to go through. So be careful of that. Then there's a table of content which will say different it will just say content of the application. Like in this test plan, what all do you have? You have introduction, you have testing scope, you have dependencies, you have activities with the roles, you have test types, you have defect management, testing tool, and how you do it. So test plan document is combination of all these different topics which should be present in the document. We'll go through each of these now. Let's start with introduction. Plus also you have to mention about this document, what this document does, even though it's clearly stated it's test plan, but still when we go to documentation, we have to fill in all the information as in like what the application is and who are the audience for it, what this document tells about. So you have to explain what's test plan document, what will it do for this project. Coming to introduction, some test plans have just introduction. Some test plan have introduction and objectives. So like two different sections. So what introduction does is like, since in this test plan, you just have one introduction. So in this introduction, you will be introducing the project, as in like, for example, the toll-free cloud is upgrading and enhancing the existing call optimization solution for, so it has the introduction to the project, as in like what this project is about. And then it will have the objectives, because in this one, we have both introduction and objective together, right? So you are telling what the project is all about first, and then you will say what is the objective of this document, or what are you trying to achieve with the help of this document, or what are you trying to achieve in this project, right? So here they are saying that there are three categories of user: free user, paid user, personal account. And there are two pledge accounts, one free and the other one paid. The user has access to SMS and can view most functions. They make money through referral and accepting advertisement. The paid user can use all the functionality, including but not limited to calling, faxing, invoice, voice recording, and neighborhood watch. The pledge user can use the information to create targeted advertisement. So here what it's doing is like it has told you about the application, what the application will do. Then it's explaining some of the functionalities, what this application is doing, right? So the test plan's objective or the introduction will say what the project is about and what are the different functionalities, plus objective is to at the end of test planning, or like at the end of testing, your application's objective will be met. So what are the objectives? Your application should be able to do all this. So that's it. So that is introduction and objective, and the difference between some companies, they have the difference, some don't. So introduction would, like if someone asks you what is the difference between introduction and objective, you can say that introduction has like the introduction of the project into the uh, into the company, and like how or what was introduced as part of this project. And objectives is like what are we planning to achieve from this application. So what will it do at the end once this application is developed? So that those are objectives. And then the next section is testing scope. This is very, very important, because this is the section which will say, okay, you know what, these are the functionality which are being developed in this project development lifecycle, or in this uh, phase or sprint or whatever, or like not phase or sprint, I would say this, because like test planning would be for complete project. So it won't be like sprint wise. It would be like complete project. So what will be present in testing scope is all the functionality which are being developed. So you see here the functional testing. So and how you will carry out those. So all the in scope part would be present here, and you have to mention this in scope testing because uh, because if you have not mentioned it here in the in scope, then there could be some functionalities which can be missed. And if there's a functionality which is missed, they will go to test plan and try to see this document. Was it mentioned here or not? So if it is not mentioned here, that means like that functionality was a miss. And people would have not tested the functionality. So that's why the in scope is required. In scope is also required because sometimes of new functionality could cause um, change in the existing functionality. So we have to mention that, okay, these are the things or these are the functionality which we are going to test in the project, and we will not be testing other things in the project. So other functionality which was not affected. If you don't explicitly mention that here, uh, it could cause uh, like money, to be honest, like in future, as in like if there's a functionality which was delivered and if there's any existing functionality which was broken because of the new functionality which is being added, the time they will come and see if there's in scope for it or not. If we have testing, if we are testing the old functionality or not. So that is being tested or that is being noted in this in scope part. So all these test managers and all QA leads, they would go through the application, try to find out what impact the new functionalities could have on the old one, and then try to rewrite it in scope. And sometimes there's a functionality which will have no impact on existing functionality. So those they would mention it in they would mention it in out of scope. So you would see it here, out of scope. So out of scope would say there are some parts which we know that it could have some impact, but we will not be testing it because either due to time, due to some other problems, or money or resource or anything. So we won't be testing those parts. So we will explicitly mention it what we will be testing in the project and what we will not be testing. So what we will be testing would be the major part, like because it's in scope, so it has to be detailed version of uh, functionalities what are being introduced and we are testing. So what are the types of user we will mention? So we are like 3 users. So all these 3 users are mentioned. Then we will be doing some functional testing. And what are we going to test? So imagine the application has like all these different functionality. So there's a number, there's extension, phone books, SMS, IVR, voice library, and etc. So I would be testing each and everything. So we would be testing dashboard, numbers, and in numbers, these are the functionalities like purchase number, list purchase number, purchase your profile, profile, your setting. So these are like different function. So these are like different icons, and each icon has like some functionality. So we have mentioned those all in scope to make sure that everything is going to be everything what has to be tested is present in the in scope part, and something which is missed here will not be tested. So there are like so many features or so many features of the application, and we have mentioned it all. And then we'll say automation testing and regression testing. So automation testing is in scope, so that means like we will be creating some scripts for automation of some of the test case. So that will be mentioned here. And then we will be also doing regression testing to make sure that the old functionality is not broken due to the new functionality being added due to this project. So we will do some regression testing. So in scope and out scope would suggest all this part. Any question in scope and out scope?
No.
Okay.
No.
Okay. So So I have explained test objective, I have explained scope in and out, and then next topic is assumption of risk. Assumptions. Okay, wow. Assumption is very important because there would be points, or there would be uh places where you would have to make some assumptions, right? And that has to be explicitly mentioned in the document, because if you don't mention it and if you assume, because there are some things which some things, like imagine we had for our example, we had like user ID and password, right? There were two fields, and we knew that we have to, if there's no requirements given and they will say like, try to log in into application, um, so we would at that point have to make an assumption that, okay, we have to either enter username or password and try to log in. Sometimes we could enter both. So there are some assumptions which you would be making in order to do your testing or test some functionality. So those would be present in these assumptions. And you have to make note of these assumptions earlier, just because that everyone are aware that, okay, we are going to test this functionality, but it does not have complete information in the BRD about it. So we are making some assumptions to test those functionality, and that will be mentioned in the assumptions. If you don't have it here, and if you took the assumption, tested it, it could lead you into problem because that is not documented here. At the end, test plan would be referred for everything what is being done in the project. So like if there's any issues, they would go to the test plan, they will see if the functionality is present. If there's something which is out of scope, which caused the problem, then they would come to this test plan, they will see, okay, that part of the application was written in out of scope, so we didn't test it. So so it's not in testing team. However, if there's something which is in scope and it was broken for user while user were using the application, that means testing was not done properly, and it would come to the testing team, and testing team would be blamed for it, right? So those are the reason why this test plan document is uh very important, and it's required. So we are clear with assumption. The next is schedule. Yeah, schedule is again one of the important point of test plan, because this test plan, it would say the schedule as in like when will each task in the software testing life cycle, which I've just explained a little while ago, when will each task be completed, right? Who would do it? And there are some companies who has defined rules, right? So they have defined like any test lead will not be executing test cases. So those are like the rules. So what would lead do? Lead would go and get status update from all the team members. That would be their task. Plus, they would see if there's any blockers which any team member are facing. So one lead will have like 5 projects assigned to the single lead. And imagine like there are 50 projects. So QA manager will have all the 50 projects. He will or she will divide these projects into like 5 team leads, and 5 team leads on in turn would then divide those projects into like team members. If they have 10 team members, they would ask them all to work on like a couple of them. So this is how the flow goes. So team leads are not allowed to execute the test cases, so they would not be executing. So what their work would be is to create like test plans, manage resources, and things like that. So that's why the role comes into picture, and the task which they do comes into the picture. And this one is like, here in this section we say activities and schedule activities and the assigned role. So what time this one will be done and who would do it. So things like that. So test plan is, what is the document? It's like describe the test approach, like what testing approach we will be taking. It will be 20 pages. And who will develop it? QA lead will develop it. Similarly, test cases. So what will the test cases have? It will have like in this phase, as in like this is the phase. So test case phase, what will it have? It will have like someone will be creating uh test scenarios. test cases, and at the end would be the test case can be with anyone, like even leads can make it, but the execution would be done from the QA only. So what here it would do is like you execute the test cases, log defects, document the results. So here you would be running the testing. So that would be the test execution. And finally is defect. Okay. Defect management. Who would do it? It's and what are the different part of it? So it's all mentioned here in this document. So since we are in defect management right now, it's a good time to discuss more about defect life cycle. Or we'll wait for some more time. Hold on. Right now, we'll just say like, log ticket, retest, and close the defect. Because I don't want to jump too much from here to there, and that could, take away our understanding from this document. So let's keep it like, then there's defect management, and then final is test report. So what happens in test report is like all these leads or managers would first create this test report document which will have details like how many number of test cases were executed, how many of them passed, how many of them failed, and if how many were not executed, and like if how many number of defects are still open, how many were closed, and things like that. So it will have like a graphical representation or like a tabular format representation of the reports of entire testing, and that is required for stakeholders and for team appreciation and stuff like that. So that is in test report. So it will say like, who would make it, what would test report include, and things like that in this section. So schedule and activity section would say each and every stage of testing, and then what do we have as a deliverable. So we'll have test plan as a deliverable, test case as deliverable in second phase, test execution as in like test results, defects as in like what is defects, then test report here. So all these are the deliverables. I hope it's clear, right? I take silence.
Yes.
Okay.
Yes.
Next would be to see what are the types of testing we are doing, right? So we are going to do functional testing, acceptance testing, or regression testing, and like regression and automation we have mentioned up, but what are the types and cycles? So we would put it here. So functional and acceptance testing we are going to do here. So we will write like the functional testing, what is required, what is functional testing. So we will mention that part here. These documents, they don't change a lot, to be honest. It would remain the same. So every company who has made this document, so this document, every company would have a template, and most of the section would remain same for them. So like being like functional. So what is functional test cases? So you will have mentioned like verify that each component is in the integrated solution function and operates according to functional requirement. Interface specifies and design document. Positive and negative test cases will be included. So what it says here is like what are the functional test cases you're going to execute, and what is achieved during this part. So you will just say that as per the functional requirement, you will be testing all the functional requirement. You will also be testing the interface, and then you will test like some positive and negative test cases. Then you will test some exception and boundaries. Exception and boundaries are required to make sure that your application um, does not break when you're testing the application with extreme values. So imagine like for the field when we were testing 58, that is like invalid scenario, right? But you have to make sure that application does not break when it's an invalid scenario. It gives you a proper exceptional output. So exception as in like, what are exception? Exceptions are like something which says, okay, you have came to a condition which is not handled by the system. So they will send out an email or a error message saying that, okay, this is not a correct way to use the system. So exceptions and boundaries. So those are very important because there are high number of situation when someone would try to break into the application or try to gain access to the application. The third one is content validation. Yeah, make sure that all the things which you see in the first page or like the pages is fine, like company name, logo. There are some tables, so table heading, names, verification, so all these things like that. So those things we would mention it, like what are we going to test? So we'll test like functional changes, we'll test like exceptional and boundary cases, we'll test like the content. So we'll say all the type of testing we are going to do. Then we will say the test cycles. What are the test cycles? So we will mention that. So that's test cycle is like simple. Will as soon as the development is done, we will test the build and report the defect. So test the build as in like once the development is complete, they would have a working software, right? The working software will be delivered to us. So we will either install the application into our environment, and after installing the environment, we will test it. And if there's any defect, we will report it. So this is test cycle and how we are going to test it. That's it. Okay, now it's the point where I introduce about defect management. Wow, this is a very good topic. So let's go back to Notepad and say what happens in defect. Let me write answer. So up until now, do we feel positive about test plan? Document is not completed. There's 1 or 2 more sections pending. But up until now, is everything okay? You understand each and every aspects of the test plan document and why it's required and why it's necessary?
Yes.
Okay, perfect. So let's move on to the next one, which is defect management. Okay, so why is defect management explicitly mentioned here? Because this causes like a lot of problems. A lot of problem as in like at the end, so imagine there are like so many scenarios. So I'll give you one of the scenarios which I have faced is like, so once a software is given to testing and tester starts to like create a test and break the functionalities. After breaking the functionality, they will start logging defects, right? What happens after logging defect is like you log a bug. So you will say that, okay, there's a bug, which is not, at first it's like, what is bug? Bug is nothing but system has been, like system is not working as per the requirement. So you imagine that you enter invalid user ID and invalid password, you click on login and login works. So that is like a bug, right? So what you do is like you create a defect or a bug, right? You create it and then you send it to developers. You say developers, okay, you know what? This was the requirement. Requirement said that only valid email ID and valid password should be allowed to give access. But when I try to use invalid option, I get access to the system. So this is a bug. Go fix it. So that is so what developers will do. Developers will see, okay, yeah, this is a bug. They will accept the bug. They will try to fix the bug for you, and then they will send it back. However, imagine a scenario, because we are in time schedule. So the designers get a lot of time, developers get a lot of time, but testing, we get very less time, very, very less time to do all the testing stuff. So we have to plan the test cases, we have to, I mean, plan the test cycle, then we have to write the test cases, then we have to execute the test cases, we have to find the bugs, send it to developers. So and at the end, they would have like as soon as the software is developed, they would say like, okay, we have only 10 days, and after the 10 days, the project has to go for deployment or user acceptance testing. So we have very less time, right? We are very time crucial. And then once we find a lot of defect and we start marking defects for developers, they get into problems saying that, okay, there are so many bugs being identified. Now, how are we going to fix so much when delivery date is so nearby? And thus the time when this part of defect management part comes into picture, that what are the steps which a QA or QA would be taking in order to uh, report the identified bug, and what cycle will it follow to to get the bug fixed and delivered to QA, right? So there are like different for various teams or various projects, various rules and regulations are being followed. So they do it that way. So coming back to my example, there was a project where we identified so many bugs, and uh, we had only 2 days left, right, for completion of testing phase, and project would go into deployment or development or deployment phase. Uh, in that scenario, developers were just like three developers, and three developers had like 50 bugs. So they they can't fix all the 50 bugs in 3 days. It's impossible, right? So in those cases, all this document as like test plan which says, or like project planning document which says like, okay, we will give sign off to the project. Sign off is the only, why do we need sign off? Yeah, now that's a question, like why do we need sign off? Sign off, without sign off, the application or the project will not go from testing phase to deployment phase. So before giving sign off, we have our own exit criteria. We will mention that at the end. So like how we will give sign off to the application, that we should not have any like more than 10 defects, more than 10 sev1, sev2 or p1, p2 defects. So things like that. So there were like three developers, they had 50 defects, and we had like the test plan has mentioned, like we will not give sign off until we have 0 sev1, 0 sev2, and maybe like 5 sev3 and 5 sev4 defects. Those were the only limits. If the number of defects is less than that, then we will give sign off that we have completed the testing, or else we will not give. So that was the project condition. And how did we know this? Because it was documented in this defect management process and the test plan document. Uh, so defect management process will have uh, steps what a team would do, or like a testing team would and development team together would do when a bug is identified. So this is the basic flow in defect lifecycle. So so there's a bug identified and it's submitted by tester. Bug is directly assigned to dev lead, and dev lead will review the bug, whether it's a bug or not, and then it will either open the bug, or it will, or developer lead would send it back. Like if the bug is real bug, then they would open the bug. If it is not a real bug, they would send it to testing team, saying that no, it's working as per expectation and things like that. If a bug is accepted by development team, they would fix the bug and send a new code to testing team, and where testing team will test the new bug and see if the bug is still occurring, they would send it back to developer and ask them to fix it again. But if the bug is fixed, then they will close the defect. So something like that. So that is a defect lifecycle. I will explain it again with the help of diagrams. So let's see how it goes. And then I'll ask if everyone understood. File name. Okay. So let's say new bug is identified. The new bug is logged, right? Then second is it is sent to development team for review. So at this stage, So it's a new bug. So status also. So let me write status. This is new defect. So after review, status is open. So once the development team reviews it, it will say, okay, so open defect, then development, you know what? Instead of making it this one, it's a decision because developers can either accept the defect or reject it. Let me remove this to make it like a decision. Review status open, and let me write this. So this is developer. It will review. If this is a defect, fix the defect. And fix will be sent to QA team. QA team will retest. If the issue still occurs, then send it back to dev. If the issue does not occur, I think this is also a condition. Fix the defect, it will send to QA team. QA team will, you know what, let me fix this here a little bit. QA team will test it, and then if defect is not fixed, send it to dev. So let's write not fixed. And if it is fixed, close it. And if developer don't accept it, then it will come back to waiting, which is here. So it's very simple. So first is like a bug is found, a bug is logged, it will send to developer for review. Developer will review it. They will say, okay, this is a defect, we need to fix it, it will get fixed. Sometimes they will say, no, this is not a defect, and you have to, this is not a defect, and then it will be sent back to QA team with the reason like why this is not a defect. If a QA team member decides, okay, whatever developer has said is working, is making sense, then they could do the test as per the new developer's request, and then they will close the defect. How? And if like if they find that okay, developer is not making sense, then they can involve BA also here. Like if there is a problem between dev and requirement understanding or anything, BA is involved at this phase. And the time again, like if there is a fix still required, then it will be sent back to developer, where they will redo the fix and then send it back to QA. So this is how the bug life cycle will work. Any question in the bug life cycle or defect life cycle? It's pretty straightforward.
No.
Yeah, it's an easy stuff. Okay. However, I need this picture for you guys. So Control S. I'll find a better one and give it to you. Okay. So that is in defect management process, like how a bug will be identified, how it will be sent to developers, and what steps they will do and things like that. So this is and there are some alternative flows of like how or what steps would be taken in order to if this flow is not if this flow is not followed. So those all things will be mentioned here. You can go through this, but I just explained the main scenario which we need in this case. Now we'll come back to something called severity and priority. Oh, this is very important topic. And this part of the document is mostly reviewed like 100 times in a project. Severity and priority level. So severity is like, oh yeah, before explaining this, let me explain you what is severity and what is priority. Very important topic. Again, asked in most of the interview, what is severity, what is priority? Okay, so severity. So severity is based on the functionality or like what is the effect of so this is all on defect. So once a defect is identified, so bug is identified. Right. So bug is identified. Now we need to understand. So we have to understand the functionality of what the bug is. Like what, how, how, uh, how severe is the bug? Like what is the impact of the bug in our system? So we have like 4 levels. So we have like critical. Okay. We have like high, we have like medium, and we have low. So we have like 4 levels of severity, right? And they also have numbers 1, 2, 3, and 4. Some company call it like with this name, some companies call it by the numbers, and some they call it with both. But so sometimes in my current company, they say it like Sev1. So this is how they call it Sev1, which means like a severity 1. So now let me explain what happens in each and every stage. So what happens in critical, what happens in high, what happens in medium, and what happens in low. So in critical, when do we say when do we say that bug is critical or critical severity? That means like we got an application and log. Sorry.
Sorry, can I ask a question?
Yeah, sure. Go ahead.
Yeah, in terms of the 1, 2, 3, 4, if you're ranking it, so would critical be severity 1 or 4?
Critical would be severity 1. So I would explain that again. Yes. So 1 is
Oh,
critical, 2 is high, 3 is medium, and 4 is low. So yeah, you will see that once when I'm explaining this high and medium and low. So that time all this will be covered, medium and then low. Right? Okay. So give me 1 minute and then
okay.
you have the question answer. Okay. So coming back to the critical. So critical is something where your application does not work at all. So that means like no one can do any work. So imagine like they develop an application, you try to install in your phone and the application crash. So that means like no one can work, right? Second time they have the application where no one can log in into the application. So that is like critical. So that means no team members are all chilling, all QA is waiting for the code, and code when we got the code, it's not working, it's broken. So that means it's sev1. So it's called sev1 critical defect. No team members can work. Example, login failure or system crash, installation failure, etc. Right? Next comes is high level. High level is something like important part of application, important part as in like important functionality of application is not working. However, we have a workaround. We have a workaround to test other functionalities, right? So imagine like in this case, when you can log in into the system, like let's take banking as an example. So you can log in into Scotiabank app properly. You can see your balance. You can uh, you can try when you try to pay a bill or try to pay send someone an interact. The interact, you can enter the amount and everything, but when you do send interact, the time system crashes or it does not work. So in those cases, we say that it's like a high priority defect, a high severity defect. That means it's called SEV2 defect. That means we can operate in application, we can do other things as in like we can see balances, we can do other functionality tests, we can create accounts, we can add beneficiary and things like that, but we cannot test interact functionality. So that is SEV2 defect and they have to fix it, right? So then comes the medium, which is called SEV3. Here, SEV3 is for when we say SEV3, SEV3 means that uh, application is slow, not responsive, uh, and functionality around performance, right? Performance related functionalities. So that would come under this part. Finally, low is like cosmetic, like logo, logo not visible properly in proper spot, the spot required, spelling mistake, colors, fonts, etc. Correct? So these are like the low. So it's called like SEV4. SEV4s are mostly like every application has SEV4. With SEV4s, like we don't care much. It can be fixed later on also, right? So those are the severity. And now is priority. So next comes priority. So severity is based on the functionality. So what we need, what functionality of an application is not working fine. So that is severity. Now next is priority. Priority is for business. It's for developers actually, but decision is based on business. So like what business needs first, right? So when I say the priority is for developers, what I mean here is like developers will choose which bug to work on first based on this, based on this priority. So they will see, okay, there's 4 priority, right? Um, high, medium, low. I think there's one more. Let me check. What do they call it? Okay, there's just 3. Mandatory, important, low. I call it high, medium, low, or like mandatory, minimum. You can call anything, to be honest. But it is like system defined, or like company defined. So some my company calls it 1 to high, medium, low. Some people call it mandatory, uh, intermediate, and low, and things like that. So I would call it high, medium, and low. So high priority defect means, so P1. So they call it like priorities referred by P, and it's called P1. So if P1 is logged, so developers will resolve this issue first, and then they will move to medium, P2, and then low, finally. When they don't have anything else to work on, then they would move to medium or low, right? And now you can say that severity is for functionality of the application, priority is for the developers to which part of the work to work first on, right? So that can be like with the help of these indicators, we will see in Jira also on how to log these defects and how it's identified and what path or what developers would work on first and things like that. So you can log like 50 defects, but how would developers know that, okay, this is something which is very important and this has to be worked on first or developed first. So they will go and see the severity in each. So if something says critical, they have to stop all their work, start working on this, fix it, send it to us. If they see high, they have to start working on this. And if they see medium and low, they can also look at priority. Some low, some low or like SEV4 defects could have high priority. So imagine that there's a logo which is incorrect. So instead of CIBC, it displays BNS, like instead of or BNS, it did display CIBC. So that is like high priority defect because it will impact the business if it goes. So developers have to, even though the severity is low, developers have to go and fix that first. Why? Because that could impact business. That could impact business related issue, the business related stuff. So that's how, like, that's the difference. So I hope we have these 2 topics covered. And anyone, if someone asks you what is severity and what is priority, you should have it on your fingertips now. Can I be positive about it?
Definitely.
Okay, perfect. Now coming back to, where is the document? Sometimes I get lost into the topic so much that I forget what I was teaching from the main document. Okay. Okay, so we were discussing test plan, and then it has like test severity and priority levels definition. So why do we need it? Because here it would say, so critical, it would say a fault that causes a work stoppage, hence no availability when there is no work around. Second one, it will say major. I called it like critical, high, medium, low, but here it's called major, moderate, minor. You can call it anything, but once you start working in an organization, it would have their own. Mostly from my experience, I've seen like critical, high, medium, low. So that's why I keep following them. Then for major, what is the major part? What is moderate? It's mentioned here. So I've explained the same thing. So I'm not going through it again. Coming to the priority says like uh, what is high priority? Incident is preventing a particular area, feature, or the entire solution from being tested and it's affecting the test schedule. Defect should be resolved immediately. So that is like priority. So this one, priority would be for developers on when they have to fix it, and this would state it. Next is test tool. Yeah, this is again very important part of test planning because we have to mention what are the tools and technologies we are going to use. So test management, the very first thing which we'll use is for test management is defect, is tools like Jira. So what Jira does is not just defect management. Jira does like uh, requirement management. It has so much more to do. So sometimes Jira, we can use Jira for everything, but sometimes we use it for defect management. So like for example, in this project, they were utilizing Jira for defect management. So that's why. Uh, they are using requirements management through MS Word. So MS Word can also do requirement management. So they are using MS Word. Uh, they are writing test cases in Excel sheet. So with the help of Excel, so they have written it MS Excel as the tool to write the test case. They are showing the results or the exit criteria or reports like that in Excel or PowerPoint. So they have mentioned the tool as PowerPoint. Now, execution, to execute, what are the applications do we need in order to test the application successfully? So first thing is we need a laptop, or else we won't be able to do anything. So first is application as one of the tool, plus we have here it says we need to have a web browser. So this is web browsers. What are the different web browsers you need for automation? You need maybe Selenium, you need Eclipse, Java, and things like that. So those tools will be mentioned here. So since we are going to do software testing mostly, so it's all software related tools. But imagine you were working for an application, what you see in Walmart. You see that there is a barcode scanner, there is a barcode scanner when you're trying to check out, right? So that time the tools would be, imagine you're testing a Walmart application. So how would you, so for those things you would need a scanner also. So in this you have to mention the scanner, which scanner are you using, the version and everything like that. So that would be present in this part. And then appendix, glossary, uh, which says like if you're using any terminology which you want to explain, you would mention it in the glossary. This is same for all the documents which you have ever seen in your life. So everything has like a glossary or appendix part. So where you have like any terms which is not very clear, or like all the terms which you are using in your test plan would be present in this section. Any doubts with the test plan?
No, not at all.
Okay, that's perfect. Looks like I'm still not caught up with everything and it's already 2:40. So I will give let's take a break now rather than going and, or are you guys, if you guys are not hungry, then we can continue with test plan, test case, or else we can come back and do it. Anything is fine with me. Where did it go? We have finished this part. We are going to do test cases. So if you're hungry, we will do this after, or else we can do it now. It's a team decision. Or if it's too much to that you have learned too much now, we can take like 20 or 30 minutes break and then come back.
I would like a break. I don't know what the rest of the team
Okay.
wants.
Yeah,
Okay,
20 or
let's take
30
a break.
minutes.
Yeah, I know it's sometimes overwhelming, right? Okay, let's take a break. And then if required, like if I at least want to finish until Jira today. So if required, we might stretch for 30 minutes if that's fine for you guys.
Okay.
Okay, that's all right.
That's
All
fine,
right.
right?
Yeah.
Okay. Thanks, guys. Then I'll see you at 3:10. Right now it's
Okay.
2:40. So let's see you. I'll see you at 3:10. Okay.
Okay, sounds good.
Yeah. Right. Okay. Validate that customer can withdraw money successfully from ATM, and then what I would do is I would write precondition here. Given ATM is online and has sufficient balance. Remember, this is the precondition. So we have to mention the precondition while writing the test case also. So I wrote like validate that the customer can withdraw money. So this is my description, this complete thing, and this is my precondition. Now I would write the test case, the steps. So what steps am I going to do? So enter the ATM card in machine. Step 2 is enter the PIN. Step 3 is enter the choose, actually not enter, choose withdraw option. Then step 4 would be enter valid amount. And test 5 would be to receive the amount and validate the amount money dispense from ATM is same as entered amount. Okay, so these are my steps, and this is the final verification which I will do. Right, so these are my steps. I have to make sure that all these steps are performed, and then final output, what I'm doing here. So in test case, you have to always mention what are you going to do. So it should always be validate, you know. So what are you validating? So you're validating that the customer can withdraw this and given condition. And steps, what are the steps you're going to perform? And what will your expected result be? So what do you want it to be? Or what do you want to verify at the end? So at the end, you will verify that amount dispensed from ATM is value what was entered, or since we would know the value amount here, we can also mention. So maybe like $100, the dollar 100. So we can say that verify that the ATM machine has dispensed 100. So this is how you would write. First, you will say validate what you're trying to validate, do the steps, and at the end you will verify whether whether this part was complete or not. So that's the strategy which I use, and I've been using it for very long. So this is one. Then you have priority. Priority as in like, what is the priority of this functionality in the application? So this is like a high priority functionality which you have to test. So for this column is required for you to know, okay, these are the functionality which I have to test first. So again, priority can be critical, high, medium, low, whatever you want. So this is like test case priority, right? It's not like a defect. Defect priority is different than test case priority. So here, if you say one as like critical, so that means like as soon as the software is deployed in QA environment, you would directly go and first test all the critical functionality. Then you would move to high and then medium. So this is how, and this is why it is required. So high priority test cases need to be executed first because that is required by the business. And then there comes a requirement alignment. So that means that every test case or whatever you're going to test right now, or whatever test cases you're writing, you would be writing it for a business requirement, right? You would get a business requirement document, you will get test plan, then you will go to business requirement document, you would choose the requirement, and then you would write the test case for this. So for example, let me show you an example of how the requirement looks like here. So this is how a business requirement documents look like. I would not go through all the details because we have seen some. And these are the requirements. So business or user requirements. So this is one of the example where you can see requirement ID here. So every requirement in business requirement document would have an ID. Either it would be explicitly mentioned, or sometimes if it is not explicitly mentioned, then you can use this one, 4.4.1, 4.1.1, so something like that. Because like for every functionality, you would have a small subsection. So you can use the subsection also. However, in our scenario, for this particular document, you have requirement ID mentioned explicitly. So imagine that you were writing a test case for this particular requirement, then you would copy this requirement ID from here into your test case, which is test case document. You would mention it in this place. So your requirement will be mapped to this. So every functionality, so each requirement can have like 10 test case. So right now, consider the use case as the requirement. So use case had this, plus use case had like function null. I would try to add like a invalid pin as a scenario. Then I would try to add functional. What was the other scenario? Functional invalid pin plus ins.
Hi, Shrey.
Yeah.
Those test case IDs, are they generated by us as well, or like those RMPT or PM underscore, like who generates them? Or is there like a way of generating them, or it's just the
No. This if you're writing it in Excel, it is generated by you because you write it. Like however, how like this is nothing but abbreviation of your project. So imagine like test plan if I have it open. So this test plan is called, so this test plan is for project called toll-free cloud application. So what if I want to abbreviate this as TFCA, right?
okay.
So this is like, so this abbreviation I'll put it here. I'll make it like this. So this will become my test case ID. So you generate this and you can have a number, you can create it. But if you use something like Jira or HPALM or tools like that, then for test case ID will go out of the play because those application has test case ID given by them, and it during that time only thing would matter is what heading you're using. This has to be unique, right? So that's how it will go. So if you're writing through Excel, if your company is maintaining Excel for test case, test plan, everything, so that time you can just use test case by yourself, or else if you're using Jira or something, Jira will have its own and they will be assigning it.
Okay.
Okay. So
Yeah.
yeah, so let's go back to our discussion, which is like, so you have 3 functionalities and all the requirements are one. So same requirements it would have. So imagine like rather than writing here different requirements, I would have wrote like same requirement ID because that's what we were getting from that example, right? So for the sake of it, I'll just write use case example requirement ID 1. Let's take this as an example. So we have like 3 functionalities in that requirement. So I'm writing it all the 3 down, right? So if I write all the 3 down, they're all linked to the same requirement. And we will see in small time, like why is this required? Why do you have to link it? We will see that in some time, okay? And then you have to mention the author who is creating this test case. And finally, there would be something called state. This is required while you're executing the test case. So imagine once an application is delivered to us, we start testing. So we would go through each and every test case and execute it. So execution is nothing but you will open the application. So for this one application will open, you perform all these 4 or 5 steps and see if it is working as per expected or not. So it's expected result this, and then there's also one more column. Let me insert it. I think it's missed. And then it's actual result. This is also very important. You have actual results everywhere. So what happens in actual result is, so this is verified, but in actual result, you will say what was done. So in actual result, you will say that ATM machine dispense $100 as per the $100. So that means like this is your actual result and this is expected result. So if these two are matching, that means your test case is passed and you can come here and you can pass the test case. So this is what. So it will say the state of the test case. So right now it's passed. Sometimes imagine that you're not testing this scenario. So you will say no run is one of the status. Then sometimes if this test case failed, imagine like instead of 100, ATM gave you $120. So that means this is not working fine. So this is failed. And this will have. And the release is sometimes people use like release management also. So release as in like there will be versions of software. So some people would do it in 2 releases, some would do in 3. So it's for them. But this is not widely used. However, the other fields are very important and they would be used. I don't know why is this AC count. Account, I think this is account as in like how many various accounts are doing this testing. So like as a user, as a bank, as a customer, so something like that. But for our case, it was just customer, so one account is enough. But sometimes you have to test a functionality with 3 users. So imagine like currently this tool has, I see different view as when compared to you guys. So like you see different stuff, I see different things. I see so many more things than you guys. So for how this application is deciding, which is like as per the user, I'm like a tutor, so they're giving me more information. And where you guys log in, you are like a learner, so you guys are restricted to a different view. So in those cases, you have to also mention different accounts which you would be using to test. So things like that. Okay, so any questions on test case document or any topics or any heading clarification? Do we know all the headings which are required in test case and how do we write it?
Sure, please,
No question.
that AC count, is it, did you explain? I don't really understand. Yeah, this AC count.
Account.
Yeah.
So AC count, like you don't really need in all the application. I've mentioned it. For us, it's imagine that you are trying to. Yeah, you know what? For time being, let's not confuse ourselves. Let's keep it simple. I will hide this column. You don't need it, to be honest. You just need the other topics which are more important, other headings which are more important, which is like test case ID, headline, description, test step, acceptance and expected results and acceptance criteria, actual result, priority requirement, other, state and release. Ignore about the AC count because that is not required. Okay.
Sri,
Yeah.
yeah, I have a question. Are we
Sure.
going to have like access to this template? So maybe we can go through it on our own as well from time to time.
Oh, sorry, can you repeat it again, please?
No, I was asking if we are going to have access to this template.
Yeah. I'll be sharing all this all these templates with you guys. Like right after the meeting today, I will share one entire folder. So this is the folder which I'll be sharing it so that you have access to it. It has not just one, it has like multiple templates. So I'll share this with you where you can go through test case. There are like so many of it. You can refer to anyone. But I'm using this one, this version. I'll update it with whatever I have explained here, and then I'll send it to you. So this one is updated, so I'll save it. And then you will have it. Okay?
Okay, sounds good. Thank you.
Okay, perfect. So I think we went through all the topics in this section, so we are good. So I quickly close this. And let's go back to our presentation. So I explain what is test case ID, title, description, expected result, and other. So we'll go to the next one, which is like requirement traceability. Okay, now this is the point. No, it says requirement traceability metrics. So why do we need this? Because you see in our test case, we had a requirements mapping column, right? So every test case, we have mapped it with the requirements. So now this if someone from the team or like a business head or QA manager asks you, you know what, give us the requirement traceability matrix. So what are they kind of asking you? They are kind of asking you like, you know, what are the did you cover all the testing for requirement traceability? As in like, did you cover test cases for all the requirements? So in Excel sheet, you will be maintaining. So this is one of the example again I have requirement traceability matrix. So what it says is like, these are the requirements. So imagine a project having like 500 or 50 requirements. So this will have all the requirements. Plus this has all the test cases. And these are like the test case ID. So what we wrote here. So we kind of consolidated all those requirement part plus the test case part in one sheet. We have to do this manually if you're doing it in Excel. So you will write here the requirements, the test case, and the requirement description. So one requirement can have multiple test cases, and it will be shown here. So there are some requirements for which test case is not present. So that means we didn't write test cases for this. And with the help of this requirement traceability metrics, we can identify those parts. So let's take one example where I want to show that there are some. I just wanted to show that one requirement can have multiple test cases. So let's see if, and also opposite is also possible. There are some times where one test case covers multiple requirements. So as in like it's testing half functionality of requirements one and half of two. So that means it's kind of testing both the requirements by just one test case. So this is one of the example. If the test case is same and it's kind of testing two requirements at one shot. So requirement traceability matrix is nothing but just to make sure that, why do we need it? To make sure that complete test coverage is achieved. So for all requirements, there's a test case, a single, a multiple, or whatever it can be. So to ensure that 100% of test coverage is done, we generate requirement traceability metrics. Earlier, it was done through Excel. Now it's very easy. There are tools like HPALM tool or Jira and everything. They do it for us. So now it's not required to be tracked like this. But earlier it was this way. For every requirements you can see here, and there are some requirements which will not have test cases attached to it. That means like these requirements were not tested, and this and then there will be meetings to understand why this was missed, why this was not tested. If they are not tested, are they being deferred to next release or something like that? Or those requirements are not being delivered or not being developed, so things like that. So those are the reason why this requirement traceability metrics is required. All good with this? Can we move ahead?
Yes.
Okay. I hope everyone is in same page. So I'm closing this. And let's move to test data. Okay, so what is test data? Test data is like there are application which requires a different different type of data to test an application. So in those scenarios, you have to create a test data in order to test the application. And for that, you would be using Excel sheet. You would say you will mention all the input columns, and then you would have input fields, and then you would test it based. So one example I can give you is, imagine a bank application, right? You are a tester in a company who is developing bank application. So to test, you should have an account of your own. So imagine you're trying to test a deposit. So you should have an account, right? So every time to go and test a functionality, you would not go and create an account, right? That would take so much time for you. So what you would do is you would go log in into an application, and you would choose, or like you would log in into an application with an existing account. So what happened to who created that existing account for you to log in and test? So that was already created. So how did that come? That came through test data. That means that those data were already present in the system. You're using it for your testing. Plus so this is one part of seeing it. The other part is like you're using data from some Excel sheet to test some functionalities or feature. So those are like test data related stuff. Next is test scripts. Test scripts, as an automation tester, test scripts could be of two types. One is like you can write a code, as in like Java code or Selenium code to validate of functionality of a website, which is automation testing. And some cases where you want to validate data, so you would use SQL. SQL we will be learning in our next session, next Saturday. So which is nothing but a database, and how do you retrieve values or data from database? So that those things would be in test scripts. Those things would be through SQL, and which is like structured query language, and we will see how to do that in our next session. So test scripts are nothing but it could be Java code or SQL, which we execute and make sure that we are getting the desired result for validating our test case. The final is defect report. Uh, the defect report has two parts. One second. I think I was making some notes yesterday while preparing for this session. Where did it go? Yes. Okay. Yeah, so I had to explain something on test report. So test report consists of two parts. One is it has test case summary, and then next it has is number of or defect summary. Let's try to see if we have any test reports open. There was one test report. Let me see if I can open it. Yeah, test report. Test report, okay. Let's see this one. Okay, so this is one of the test report document. Test report consists of two parts. So we have studied test planning, test scripting, execution, defect lifecycle. Now this is the final stuff which we are want to learn now. test report has two parts, which is don't want to write everything, so let's keep it simple. Okay. So it has the first part says test case summary, where it would say number of test cases which are passed, number of test cases which are failed, number of test cases which are in no run, and okay, no run or blocked. Blocked means like you can't execute those test cases. So let's see what this the meaning of number of test cases passed. So you have a functionality which you're going to test, which has like 50 test cases in total. So there are test cases which are for one function, for one entire project is 50. And you're going to test that, right? So what you have to do. So you get the project, you start testing. Out of this 50 test cases, 40 of them were executed, right? So you will have number of run is equal to 40. Then you will have like fail. So out of this 40, 10 failed, right? And then out of this 50, maybe 10 were not run or were blocked, right? A number of test case passed would be like 30. So how did I come up with this scenario? So there was an application which I was testing. It had 50 test cases in total. When we reached execution state, out of 50 test cases, we could execute 40 and 10 were blocked. So those are written here. And then out of the 40 which we tested properly, in that 30 was like completely passed, no issues identified, and out of those 40, 10 were failed. So what did I do here? I just wrote a summary of my testing. So in summary, I have noted down all these things. So that is like test case summary. Similarly, I would do the same for defect summary. So what defect summary would have? It would have number of defects found, number of defects open, number of defects closed, and it will also have severity assigned to each defect, right? So those would be mentioned in defect summary. So now we'll see that in a document. Now, since we know what are the what are the what are the what are the things which we are testing, or like which we are checking for defect summary. So like defect found, number of defects open, close, and things like that. So once we've gathered all this information, we are ready to create our test report. So we'll see one of the examples here. This is test report or exit test report. You can call it anything. It has all the other documents like testing. You have to make all these documents because these are the only things which are reviewed by high level people. So you would still mention what this document consists of, and what are you going to, what are you having in this document. So it will have, so these are the contents. You will have audience, reference material, testing, in scope, out scope, test environment, availability, execution process, test case statistics, defect, and test assessment. So I'll go directly to test case statistics because this is what I was referring to. So here it says that we planned 42 test cases and executed 42 test cases, passed 42 test cases. So that means all the test cases which we tried to execute, they were all passed. So there's no failure or nothing blocked or nothing failed. So these are the test statistic at the end of the report. So we will send this report at the end. And then it says, what are the test cases which we executed? So see, here we have like the test case ID, what I was mentioning in test case, and then we have the heading. So with the help of this page, you are just saying that what are the 42 test cases which you have executed. So it will also, since it has like the test case name, it has the small abbreviation of project, and the headline also says like easy way to describe what you tested. So it's such an easy way to show, and people will know what you have tested. So all the 42 are listed here, and then there is a defect list. If there was any defect identified, that would be present here, but unfortunately, this project or this template does not have any defect, so there's no defect mentioned. And then you have test assessment, like how did you assess the test and things like that. That's it. So test, there's one more document I think I have, which says a graphical way. Let me find if I can find that.
Sorry, Shrey.
Yeah.
For the defects, when we have the action plan for defects, is it us recommending what needs to be done to fix the defect?
Hold on. Where did you see that?
If you scroll down to defect, yeah, there we go.
So action plan.
Mhm.
Yeah. So if some defects are not fixed, because now you have, if you generate a test report, that means you have finished testing entire software, right? Entire application. So right now we don't have any defect in this, but however, if we had a defect, imagine that there was like one defect here, 1 and 2 defect, status is um, open or in progress, anything. And then the severity is mostly like 3, priorities like 2 or maybe like 3. So all the defects which goes unattended would always be like severity 3 or 4. It would not be higher than that. So all 7 and 2 would be close. And then it will say like what issue is still existing. And there are also possibility that some defects which would take like long number of days to finish, even though they are like Sev 3. So those will also be, there would be some functionality which would be deferred. So action plan for them would be to deliver. So all these defects would be deferred. So deferred as in like it would be delivered in the next phase of the project. So whenever there's a next plan. So in action plan, you would say deferred until next release, right? So these defects would be fixed later on, or your action plan also could be like provide a patch fix. So a patch fix is nothing but your product is delivered, and then like how in even in Apple or like Android phones, if you guys have, you would see that every now and then you get an update on phone, right? So that is nothing but a patch fix. Patch fix is like the entire operating system is not replaced, but a small part of the code in the existing place would be fixed with the help of small jar file. So they will not fix the entire application. Just one file will be replaced in your in your program. So that is there. So this is how like the action plan would be to either provide a patch fix or provide like or fix this defect in the next release. So once there's a next release, we will test these defects and fix them. Okay. Are we good with the explanation?
Yes.
Okay,
Yes, thank you very much.
no worries. Oh, I think I've covered it. I wanted to show a graphical way of this part, but I don't think so. I have any at this point. But how when we try to learn Jira, we will try to create one graph there. So we learn it there. But I think now we are good with this. Coming back to our this perfect. And IEEE 829 is the standard. Like it's like a regulation which has set a standard for all testing deliverables and how the document should look like, what template should look like, and things like that. So this is so we should, all the companies who are like tier 1 who does testing for all the application, they follow these standards. And then there is agile docs. We will see about agile docs while going through Jira, right? Because all the test cases, subtasks, story, we would see in Jira board. So let's do that. Quickly, before going there, I want to see if there's anything which can be completed at this point in this. Okay. So test progress communication. Yes, we have to. Yes, for test progress communication happens when we enter or as a team enter into testing mode or testing phase. When testing starts, we have to make sure that we document all the test results. That's first. And we keep the team updated with how our testing is going. So at least like that, keep the team lead or manager involved. If there's any problem, communicate it. Uh, communicate as in like meet, send an email through phone or report, formal, informal, however is possible. If you are a team lead, make sure you keep appreciating your team for all the hard work they are doing, and keep the communication like short and crisp. Like make sure that you are communicating in a way that you're not taking, you're not kind of explaining in very detail, so that people will take at least 10 minutes to just go through the email. So keep your communication as crisp and small as possible, and be like trustworthy. So as in like do your work properly. When you say that you have uh, completed testing a part of the project, make sure that you have really tested it rather than just saying that, okay, I've tested it, because that could uh, impact business plus the reputation of the team in together. So why is this required? Why do we need test progress communication? Is like if there's any hurdles which you find during testing, if you convey it to right people at right time, then there can be like risk analysis, risk or risk or late delivery issues which can be tackled if the communication is done well ahead of time. So that's why it's required. So while testing, if there is any progress, just keep telling or keep all the team members notified would be good. Next is estimation technique. So this is not like a very big topic, but I would just say quickly on what happens here. So every project has this estimation, no matter it be a mechanical project, software project, like even a bakery project. So all has like estimation technique, right? So what happens in estimation technique? So we have to find out the estimation of the project, or how much how many resource we need. The first thing would be resource. Second would be how much time, how much human skills, and how much cost is required. So those things are the estimation which we have to do. So let me quickly note it down somewhere. Okay. Estimation. So estimation could be for resources, and estimation, I hope you mean software project estimation. Resources, time required, then human skills and cost, right? So how many resources, what's the time, what are the skills which a resource should have? Obviously, if we doing some automation testing, make sure that the resources whom we have has knowledge on programming, knows about the tools which you need to automate, and then the cost involved. So what's the cost of the project? So all these things are required for estimation. then how do we do it? Like, what is the strategy which we have to do it? So they say that we follow a breakdown structure. Right? So there's a big project. We will try to first divide the project into modules, then divide each and every modules into sub-modules, and then divide sub-modules into functionalities. So this is how we do it. So we have a project. First, we divide it into a tree structure. We say, right, okay, there's a login functionality. There are like five modules, right? So we would first divide into modules and then divide each modules into sub modules, and then again divide sub modules into functionality. This is how we break down the project in order to successfully do an estimation. So, given an example of software development life cycle, how do we break down? So first we would do is what we see. First we would do requirements. First we would have like requirements. Then we would have test specification. Then we will execute test cases. And finally report the defects. So these are like the various work breakdown structures which we will have for our testing. So we get the requirements, we write the test specification, we have execution, we have to report the defect. So all this would be our breakdown strategy. And after breaking down, so first is like breakdown and then finally do some estimation on it. So let's see how estimation is done. So to do an estimation, now since you have all the tasks divided into functionalities, now you know like how much time each functionality will take to develop or test, right? So since you have all the functionalities, you would first estimate how much time each functionalities will take. You will add them up, and after adding them up, that would be your estimation. So based on the time, based on the human resource, so the estimation will be resource, time, human skill, and cost. So since you have broke down everything into small functionalities, you can identify that and then join everything and make this final estimation. Right? So I think that's an easy part. That's what is written for it. That's what we should know about estimation. Oh, I hate this. Okay. So work breakdown structure, bottom-up approach, which is like you're trying to break down the structure into having a project breakdown into modules, then broke down into sub-modules and break down into functionalities. And then from bottom, you're trying to find out what are the what are these factors which is mentioned here? What are the resource, time, and human skill and cost? Then you make a metrics from, and also you utilize the metrics from past project because every project is different in nature, but again, it will have like similar facts from the previous project. So you will utilize the metrics from past project in order to devise the estimation. And again, it will not be exactly the same as previous project, but this is just to get a rough or approximate value. It's not like complete same value. So we'll do that. Then again, quality takes time and takes money. So these are all very interrelated with each other. Plus, and this estimation technique is about will take about like 1/3 of developers' time. So like if you have estimation technique done properly, it will help the team for sure. Coming to risk management, we have to think about risk at all stages, no matter when in the project or whenever we are in the project. So we have to take things like organizational risk. So for risk, let me go to this part. Risk management. Let's make it organizational risk. Means what is organizational risk? So this is like risk related to human resource or the testing team, so HR or your testing team. So for example, I can say, imagine that you have a team member who's not as skilled, uh, who does not have the skills to do the job. So what would that do? That would introduce risk in your project, because that part that part of work can't be done. So imagine there's a developer who does not know a language which project is using to develop an application. So he does not know HTML or Java or CSS, one of the things, and he's trying to develop a front end application. So that would impose uh, a risk in your team for for the reasons of lack of technical skill, right? Risk due to lack of technical skills. And then hence you have to keep checking that all the team is well organized, and does the team member have the risk, and does the team member have the skills required to do their job. So that is organizational risk. Then we have
Sorry, Shri, I have a question. Are
yeah.
these risks for all projects, or like, as in, are they all general risk, or like we have special,
I
like,
think they're all projects. They are not like just software related projects. I mean, not for just specific project. It's for all software related projects. So imagine that you have a team, and you are an automation team member, and you have a person who is just manual, or who has experience in manual testing, who does not know anything about automation. And now together as a team, you have to develop an automation application, automated test. So since the other team member not aware of automation or like programming or anything, how would it would be unfair for you to deliver, because projects or like the company, your team lead or manager would be expecting you to deliver the automation framework in like 15 days. But since you have a team member lacking in technical knowledge, now you would be taking like 20 days. So that imposes like a risk in the project delivery, right? So that is one of the risks. And to answer your question, does it change? Yeah, it changes for development. Uh, it changes for testing team, but risk still always remains the same. And also, then there could be a technical risk, and technical risk could be, imagine if the technical process which we chose was wrong. Technical process chose was wrong, or uh, something which was untested. So all these things would cause like a risk in project. So you have to make sure that all the functionality has been tested properly, and the technical procedures or testing procedures which we have taken is is optimal, and it will work fine. So for how would we attend this is like by having experience working into the project and things like that. So this would anyways be done by high experienced people in the project. So as a team member or as a lead or any or as a team member or lead, you have to always make sure that you continuously assess the risk. Like you always go through the plan and try to assess the risk, like, and make sure that uh you find the risk and report it and try to get it fixed. So the risk could be in any of the scenarios. You may not have imagine your project has like only 2 weeks to finish testing, and there's only 2 resources instead of 5 resources. So you have to get that into you have to tell about those to higher management before. So risk could be due to human resource. It could be due to human resource, sometimes testing environment. So testing environment as in like there are some external tools which you need to test and test the functionality. And if you don't have those tools, how would you be able to test it, right? There are sometimes which there are application which requires high Windows capacity, which is like high memory, high RAM, and things like that. So for those, if you don't have a laptop which is suitable to do those tests, then again you would process a risk. Then you should make sure that budget that your project is in budget, and like if budget is cut down, then again there is a risk. And also one more risk is security features in web application, because what if because this hacker can then hack into your application if you don't have enough security installed in, or like enough security measures taken while building a website. So that could be one of the risk. And I think we have covered almost all. We have covered organizational risk, we have covered technical risk, we have covered human resource, environment, budget, security. So yeah. So those are like different risks which we have to keep in mind, uh, even not just before planning the project, even during the project, and make sure that if we find any or if we anticipate any risk, we tell the concerned managers or teams like well ahead in time. That way, we will save ourselves from any big or major losses. Final would be change control management. Change control management, yeah, is a type of risk. Always think of what effect it would have on testing, communicate effects to team. So, okay, so what is change control management? So change control management is nothing but, so let me write here, change control management. Okay. So we build application, and in software testing, there's always changes. So business would think about the application some way, and they would document it, and the developers will develop it in their own way. However, even when there's a 90% match, there's 10% which would match with the requirements given by developers, and requirements given by BAs and understood by developers. So at the end, business has to decide like what they have to do, whether they want to you know whether they want to accept the change. And if they are not wanting to accept the change, they will say that, okay, there are these functionalities which we didn't want it to work this way, but it's working this way, and now we want to change it. So that time change control management comes into picture, where uh, and also like this happens in two scenario. I have mentioned one, and the second one would be that business has mentioned an application to work one way, and once we deliver the software, they change their mind. They are like, okay, you know what, this is not looking good, and we want this to look something else. So that time change control management comes into picture, where there's a process which has to be followed, and based on the process, uh, the new change or whatever it is will be implemented. So let's go over what are the changes and why or how this change control management is implemented. So what are the source of changes? Let's say the source of change. This is very important. And as per my explanation, it is for multiple reasons, which could be business reorganization, could be new market condition. New market condition is like, what if there's a feature which is no longer required, and there's a new feature in market, maybe marketing through TikTok or marketing um, through Instagram. So that is like new feature right now. So now all the marketing products which people are building, they want it to be directly sent to Instagram page or like TikTok page. So those are like the new change which they want. So those would be due to new market condition, and some would be for fixing any bugs or errors. So this is some of it, and some could be based on performance. Like what if application is taking performance? So what if application is taking 10 seconds to load, and business wants it to load in 3 seconds? So that is like performance related control change. And then finally would be, imagine that there is like, this one is scheduling constraints. So imagine there are like 50 functionalities to be delivered, and only 30 was delivered due to time constraint. So how would this scenario handle through change control management? So change control management is a process where first you have to understand the change, and if there's a change from the design, change could be for multiple reasons. These are the reasons, and once a change is identified, what process are we going to follow? That is the next. So I'll just briefly explain like what happens in the process. Once change is identified, business will create a change requirement document, and then it will send it to change and or like a project team will create a change requirement document, and it will send it um to the business for approval. Because if business approves for this change request, which is called CR, change request, then they have to pay money in order to fix those changes. It's not for free. So that's why this is a very important part, where like they have given us like maybe $1 million. We developed the software, given it to them, but now they are saying, okay, these are the feedbacks. We want like 5 new functionalities and 5 of old functionalities to be amended or be in a different way. So we make a change request and we give it to them like, okay, this will take 20,000 extra. So then business will approve it. Okay, we'll give you 20,000 extra, give us this new change. So it will come to us. We will start developing the next phase of the project uh, with the new functionalities added through change request or change management. I hope everything is clear on this. Uh, then what are the areas? What it could affect is the scope of the project. Yeah, because of change request, what are the effects? Effects because of change request. Yeah, this is important because it could affect the scope of the project, This is, I think, straightforward, the scope of the project, the schedule of the project. What if the functionality which they want to add is like very critical and like takes a lot of time, so that would play with the schedule. Then project cost, obviously, if the change request is for any change request we call the project cost is involved, we will ask more for more money. Simple. Quality, make sure that we have enough time to do the testing of of uh, of the call of the new functionality coming through the change management. So quality will be one part. The next is human resource. So for all, if there is like crazy change in the system, then we have to make sure that we have enough resources to handle the change. If not, then we might have to hire more people, so things like that. And then we have to make sure we are uh, communication or risk of improvement. So risk, communication, and procurement are final things which could have effect on change request. So change request can impose some of the risk which was not identified earlier. So again, risk has to be recalculated and assessed. Communication is make sure that after approval, uh, we change the after approval of change request, the communication is done to the entire team. So that is why the communication is required. And procurement is a change request can affect what we say, it can affect effort for material and contract labor. So if we have more, if we have contractors or yeah, if we have contractors, so it would affect cost of those contractors. So those things. Anyways, because of change request, there would be all these effects and all these part of software development team or lifecycle team would be impacted. By this, we finish this section and we have not covered Jira today. You know what? Quickly, I would go through the Jira and then you guys can practice it yourself. And we will discuss on like first few minutes of our next Saturday session on what on any doubts if you guys have. Is that fine? Because I have a project myself, like created it yesterday. So I'll go through it. Let's see if I have. Oh, shit. Okay. So I created this website yesterday for myself. You can follow the same. I have my name, Shukran. Let me see if I can delete all the project. Okay. Move to trash. Move. Save project. So when you guys do the installation tomorrow, or like whenever you have time, if you go to this website, it will take you to this page here. You can I have my work email here. You can have a different work email. I don't know if do you guys have busy QA email? Not right.
No, no.
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 Okay, perfect. Then you can have your own Gmail entered here. It's free anyway, so you can have your own Gmail ID entered here. And then you can take a name, or like you can choose one of the name. I use Shrikant Kumar, so it worked for me. So you can try, like, if your name is not available, then you can choose something which you can remember. So make sure, but you remember those things because you might need it. And then after doing it, you agree. So then they will send you an um, then they will send you from Busy QA. They will send you, where is it? Um, Zoom, Atlassian, yeah. So they would give you a Jira where it will say to, not here, actually it's here. Okay, they'll send you something like this to verify your email. Once you verify your email, you will have this setup. And then once you try to log in into the application, you would see this as the first page where you have to create a project. It would directly take you here. So for our project purpose, we are going to do or practice Scrum. So it has like a template. So you just say use template. And then for this one, say company managed project and add project details. For time being, I'll use AT QA. So I will just write a project name. So I gave project name as BZQA, automation testing team, and then Q. I'll do next. So Jira would create a project for me. So you would see a project which looks like this, and this is a Scrum process project. Here we would first go into backlogs, right? And so here I can say, here I can explain more about this project. But again, since we have reached time, you know what? Let's do this on next class rather than doing it right now in a hurry. I don't want to do that. Maybe it's already 4:30 and you all might have plans. So if you have like 30 minutes, I can go over it today, or else I we can do this next Saturday. So it's up to you guys. Let me know what suits.
Next Saturday should be better.
Okay.
I think.
Yeah, let's do that then. Let's do this
Yeah.
next session. Yeah, I understand that it's too much of information plus yeah, let's do it next session. This session I'll try to come up with some easy assignments, and it would be mostly related to test plan, uh test case and things like that. So I will share all the notes today before end of the day, so that you can all have it. And plus I'll share all the templates from my side.
Thank you so much.